Good evening. Since this is the first large public meeting we've had, it might be helpful if I took a minute or two to explain who we are and why we're here. This is the Joint Steering Committee on Resource Recovery, which was appointed by the Mayor and Council. Certainly. Hear me better now? I'll try to speak up then. This is a meeting of the Joint Steering Committee on Resource Recovery. This committee was appointed by the Mayor and Council a little over a year ago to deal with the Wheelabrator Frye application to construct and operate a plant in the Edgeboro landfill to burn garbage and produce electricity from that process. The committee is not a decision-making body. We're here basically as an advisory group to study the application, to raise issues, and to gather facts, and then to present them to the Mayor and Council for their action. At this point, we have met a number of times throughout 1982. Most of those meetings occurred during the first quarter and early part of the second quarter, and when we reviewed an initial application that was presented to the state by Wheelabrator Frye. We presented a rather extensive evaluation of that application to the state, and that resulted in a resubmission by Wheelabrator Frye, which has been placed in our hands, or was placed in our hands around the 1st of January. That application sits here beside me. It's roughly some 300 pages long and has not yet been submitted to the state in any formal way. This is a work session for the committee so that we can continue our review of the application. Wheelabrator Frye requested in early January an opportunity to work with the committee in its review of the application, and the committee granted that request in a limited way. By that I mean that we suggested to the applicant that they prepare a presentation of the application, which they're going to present this evening, and that they be prepared to answer questions from both the committee and from the public. Now, we've supplied them with a list of concerns and major issues that we think many people in the community have in mind, and I assume that they'll be prepared to respond to many of those this evening. In addition to that, although I haven't read it, having just received it tonight, they've given us written responses to many of the questions that were raised in our evaluation of the initial application. Now, insofar as our agenda tonight is concerned, I don't know for sure how long the applicant's presentation will be, but we will have that. We'll have questions from the committee, from the staff, and when those have been exhausted, then there'll be an opportunity for the public to ask questions. I want you to understand that this is only the beginning of a very long process. The process has been ongoing for almost a year now, and it could easily be another year before the state finally acts on the application. So there'll be many more opportunities both for us to ask questions and for you to ask questions and for you to make statements and provide us with information, which we welcome. But when the time comes for the public portion of the meeting tonight, I would like to limit that to questions on the presentation and on any aspect of the application. But unless we end up with more time than I expect, I would like to hold back on any additional presentations that anybody in the public might wish to make, or any statements that you might wish to make. There'll be plenty of opportunity for that. Now, in that regard, our next meeting will be February 23rd, and as always, our meetings are open to the public. That meeting will be held at 8 p.m., more than likely in the large conference room with the municipal building. And for the committee members, you might be interested to know that the council informally agreed on Monday night to authorize funds for the air pollution consultant that we propose be hired. I think formal action on that will be taken next Monday night. And Mr. Tanner, I ask, you think it would be possible if the council acts on the air pollution consultant's contract next Monday night, that he might be able to be with us on the 23rd and at least give us an initial impression of the application, although I'm sure we won't have an opportunity to get into it in any depth.
I'll get in contact with him tomorrow morning.
Fine. Now, I think at this stage, I'd like to turn the meeting over to the applicant. I see Mr. Ferrante, who has been heading up this project for Wheelabrator. And Mr. Ferrante, the floor is yours.
First, let me thank you, Mr. Chairman, and other members of the steering committee for the opportunity to be... Can you hear me? Okay, good. I want to thank the members of the steering committee for the opportunity that you've given us tonight to address you and the citizens of East Brunswick on this project that has been under development and consideration for quite some time. We have with us tonight a number of people who are responsible for taking the project from a stage which the township observed almost a year ago at our application to the state to a point where we are now just about ready to complete an application, and we'll be submitting it to the state in March, sometime in March. We haven't set upon a precise date. I'm getting a little wary of fixing precise dates. But we appreciate the opportunity because we think we've reached a point in the development of the project where we've completed a number of key studies which had not been completed at the time of the March '82 submission, and we have a good bit of data to share with you. As I mentioned, this is the site registration application. As Mr. Dannon mentioned, there are a number of other permits that are associated with this project that will have to be obtained in addition to site registration. What we're focusing on here tonight and what we are addressing in our application deals with registering the site near the Edgeboro landfill for a 1,500 ton per day resource recovery facility. What we hope to do tonight is to give you some background on the project, briefly cover some basic fundamentals, and then move into the nature of the project as it is proposed. Then we will move into an analysis or a summary of the analyses that we have performed in conjunction with the environmental impact statement, which we will be filing with the state next month. And at the end of that series of presentations, we'd be happy to respond to both the committee's questions and yours. What I would like to do at the outset is to lay some fundamentals before you. We all come to this, those of you in the public, come to this project with varying levels of understanding, and I want to quickly go almost to ground zero and rapidly bring you up to where we are and why we are here, and why this type of technology is being offered to Middlesex County and the state of New Jersey. So I'd like to begin with a series of slides. Following me, we will have a technical discussion of the process from a design standpoint. We will then go into an operational discussion based upon our experience in owning and operating these systems, covering some of the issues that have been raised by the committee. Then we will go into looking at the project from a reverse perspective, how it affects the environment at large. And we'll examine it from a number of key issues: air, water, residue disposal, and then close the presentation for questions. That'll be the basic format that we hope to pursue. So I'd like to begin with the slides that I've prepared. As I say, I'm going to start with some fundamentals. Please don't interpret it as being spoken down to, but many times in these discussions, a definition of terms is a very important one to begin with. I want to relate what we're doing in this state to the basic reality that is confronting everyone in the world. We have a number of affluent societies, and we're producing more and more waste. Surprise. No surprise to people in Middlesex County. Now I want to define what we mean by that waste. This is a pie chart which represents the distribution of what we call municipal solid waste, the constituent elements that are found in household waste, in local commercial waste, in office waste. This is the subject matter, this is the commodity that we will be dealing with when we talk about resource recovery and processing waste. As you can see, we've divided it up into two broad categories. Those parts of the waste stream which are recyclable, and those parts of the waste stream which are combustible. Recyclable including aluminum, ferrous metals, glass, rags and rubbish, corrugated newsprint. These are traditional sources of recycling activities in this state particularly. And preponderance of the waste stream is combustible. This represents a sampling that we conducted for a 2-week period at the Edgeboro landfill, and it is documented in our environmental impact statement. The significance of this slide is that it represents basically the same components of waste found throughout the world in other affluent countries. We hear a lot about my garbage is better than yours, yours is different from mine. It's all basically the same. We find variations in moisture content. For example, Japan has more moist refuse, but at the same time, they have more plastic in their refuse, perhaps 10 or 15%. It ranges. This happens to be about 7%, which is what we found in the constituent elements, the constituent components of the Edgeboro municipal waste stream. Quickly touch upon the fact that the technology that we're going to be talking about tonight is not experimental technology. It is widely adopted throughout the world. Again, the same basic commodity being used. This will give you an idea of the number of the major countries that have adopted resource recovery technology like the one that we're proposing for Middlesex County. Major countries like West Germany, where 23,000 tons per day in 39 plants are being used right now. That's equivalent to all the waste that New York City generates. Japan has 85 plants with a throughput of 44,000 tons per day, or roughly 3 times what the entire state of New Jersey generates per day. So the technology is not something that is untried. This is how that throughput relates to a per capita waste generation. We normally consider a person as generating about 3 to 3.5 pounds of municipal solid waste per day. As you can see, these countries have achieved significant diversions from land disposal through the use of resource recovery technology. You got to get all the way down to the United States to where we're doing about 1/10 of a pound right now. I'll quickly go through. This is what the plants look like. This is a Swedish plant in Göteborg with a throughput of about 1,000 tons per day. This is a plant in Bremerhaven, Germany, which uses the latest technology, a scrubber, to perform acid gas control. And it is roughly 1,000 to 1,500 feet from the residential units. A Japanese plant. The first of these plants ever to be built in the world in Bern, Switzerland, capital of Switzerland, and as you can see, close in close confines to residential apartment uses, as well as some single-family townhouses. In fact, this is a picture of one of the refuse trucks coming down an exit ramp and an apartment house that is within 100 feet from that plant. That plant has been operating since 1954, and last year, the citizens of the canton overwhelmingly approved its expansion. The reality then, from a worldwide perspective, is that people have recognized in Europe and Japan that we have limited land, that there are environmental concerns to be addressed with land disposal, and unlike us, until recently, they are aware of the energy value in municipal solid waste. They have opted for an aggressive program of resource recovery and recycling. In the United States, same basic parameters. And this one, that is gaining more prominence locally as landfills are forced to upgrade with environmental improvements and as capacity limitations are reached. We're facing the fact that we have to turn to alternatives. In this country, that was recognized in 1976 with the passage of the Resource Conservation and Recovery Act, sponsored by two key New Jersey legislators, Congressman Florio and McGuire. It addressed the issue of dwindling land disposal and set a priority for the adoption of resource recovery technologies throughout the country, particularly in urbanized areas. Yet, this still is the predominant means of waste disposal in the U.S. New Jersey actually predated the U.S. in coming to grips with the concept of alternatives to land disposal. In fact, in 1975, the state enacted Chapter 326, the Solid Waste Management Planning Act, in which it mandated the 21 counties and the Meadowlands Commission to adopt a planning process which gave as a priority implementation of resource recovery. This is the reality that faces New Jersey. In 1970, we had 365 landfills. In 1983, we have 168. But the key issue is, or the key dimension, is the fact that we have 15 landfills in the state that handle 75% of the waste. And those landfills are rapidly reaching their limits of capacity. We come closer to Middlesex County. This is what we generate per year in waste, both processable and unprocessable waste. About 1,200 pounds per person. A family of 4 generates slightly less than 2 tons, enough to fill an average-sized bedroom. This is the reality in Middlesex County in terms of cost and availability. Those of you who live on the eastern side of the county will recognize this phenomenon associated with global landfill, charging $5.50 per ton as recently as 1981, and now charging over $20 a ton for disposal, a consequence of increased environmental requirements as well as capacity limitations. That situation is duplicated by another large landfill in Middlesex County in Edison, the ILR landfill, which is facing the same capacity limitations and the requirements to increase its disposal fees. Edgeboro, closer to home, has undergone this kind of rate change in the last few years. Recognition of the fact that improvements are required and we have to pay for them. The fact is, as space declines, the cost of disposal increases. This is a reality that not many people are aware of, yet it represents a scenario which is not highly improbable. It shows that in 1986, if the current trends continue, that this county will be faced with the prospect of siting a new 135-acre landfill to satisfy its waste disposal needs to the year 2000. Those of us in Middlesex County tend to feel the luxury of having readily available land disposal. It's going to be here for a long time. Why worry about it? Fact of the matter is that unless new landfills are open in other counties, and unless new landfills are, or unless landfills are expanded in the northern part of the state, this county will be without land disposal for its own county-generated household solid waste. There will be no disposal resources in the county by 1986. And what will be required to satisfy county-generated waste through the year 2000 is a plot of land that's the equivalent of about 400 to 500 residential lots, buried about 40 feet deep. With resource recovery, the land requirements are dramatically decreased. In fact, less than 1/7. The county facing this prospect and analyzing the various scenarios that appear in terms of waste disposal, the quantities coming in, the inability of other exporting counties to solve their problems, has opted for a balanced approach to satisfy its own waste disposal needs. It features recycling, resource recovery, and landfill. Recycling, basically curbside, local recycling programs are to be expanded from a present level of about 1.7% to a goal in 1984 of 5% to an ultimate goal of recycling 25% of the municipal waste stream by 1990. A very aggressive goal. But this still leaves a significant portion of waste that must find a place for disposal. The other part of the choice that the county has made is resource recovery for these reasons. First and foremost, bulk waste reduction, energy production, and environmental improvement. Let's look at what we mean by bulk waste reduction. This is a cubic yard of municipal solid waste that would be carried on a packer truck. In an ordinary landfill, we can compress that through compaction to about 1/3 of its volume. By processing through a resource recovery plant, we reduce it to 1/20th of its volume, that being the ash that is required that requires disposal. We also extract considerable amounts of energy from the organic portion of the municipal solid waste stream. A plant such as proposed for East Brunswick, with 438,000 tons of throughput annually, will generate a gross power of 250 million kilowatt hours, or the equivalent of 26 million gallons of oil. And very little of that energy is used for plant consumption. In opting for resource recovery, there are three basic considerations to take into account: siting, technology, and financing. We responded as a company to the county's specifications in all three of these areas, and they are contained in the county solid waste management plan, which was approved by the state. In terms of siting, the county prescribed an area called a gray area, basically in the central part of the county along the Raritan River, where it was deemed feasible for a resource recovery plant to be sited. Specific siting, however, was left to the project initiator. Technology choices, again, were made the decision of the private developer. And finally, and I'm leading to it, the financing responsibility in view of the substantial tax benefits associated with it, with financing these facilities, and the benefits that that form of financing bestows on the public in terms of tipping fees, was delegated to the private sector. We responded to those three criteria as follows. We examined a number of locations along the Raritan River basin, covering about half dozen towns, from South Amboy on the south banks of the river through East Brunswick and to Edison, Woodbridge, Perth Amboy on the northern part. This is the proposed Edgeboro-Resco site at the northern end of East Brunswick Township. This is the outlines of the property that we are acquiring. The site will be on a portion of that property. As you can see, key determination being its proximity to the New Jersey Turnpike and good access roads through 18 and Edgeboro. Another key criteria for the site, and we'll talk about this later in the discussion of the environmental impact in the process, is direct access to the Raritan River for water requirements in our process. Direct access to Edgeboro disposal, the landfill, for residue disposal requirements. This is the nearest residential development, about 3,000 feet from the portion of the site that will be situated for the plant. We didn't build it yet, but what we did, we took an artist and asked him to sketch in the plant as we perceive it in our rendering on the site as it exists right now. This perspective of the plant is from the bottom of the residential community, 3,000 feet, roughly 3,000 feet from the plant site. You can see in the background on the northern bank of the Raritan River, the existing ILR landfill. Those are refuse trucks. This is another perspective on the plant as viewed from the New Jersey Turnpike, crossing the Turnpike Bridge. Plant, and this is the toe of the existing Edgeboro landfill. We selected the technology. As I mentioned, the technology that we are using at this plant and other plants that we are building right now has had widespread application throughout the world. It is the Von Roll technology in application in over 170 locations worldwide. This is the plant in Saugus that uses basically the same technology. We have looked at other technologies. Resource recovery is a generic term. It embraces many technologies. Many technologies have been experimented with, particularly under the sponsorship of the federal government and the Resource Conservation Recovery Act. Many technologies have failed. Many technologies have proved unreliable. This technology has a track record of 30 years. It's been improved over that 30-year period. That's why we have selected it for application in this state. This is a technology that failed. I don't know if anybody recognizes the skyline. That's the city of Baltimore. This was a technology called pyrolysis, taking municipal waste, shredding it, and putting it through a furnace under somewhat starved air conditions, supposedly to create a fuel byproduct. It never worked. It cost the city of Baltimore, the state of Maryland, and the federal government about $40 million. It is now being dismantled. We are dismantling it, and we are building a plant on that site about 50% larger than the one that we're proposing for Middlesex County. The same technology, our financing, and the salvage value of that pyrolysis plant was about $400,000. I mentioned financing. the county's third decision was these resource recovery projects are businesses. They're not public works projects, they're businesses. They should be run as businesses. We have adopted that in our Saugus plant, have run these projects as private businesses, and we have continued that philosophy in Westchester County. That is the offering statement associated with the issuance of $157 million worth of tax-exempt industrial development bonds, which represent about 75% of the capital cost of a project being built in Peekskill, New York. Wheelabrator Frye is the managing partner through a subsidiary in joint venture with the John Hancock Insurance Company. We both put in equity. We both have made a long-term commitment. We both are standing behind the design and construction of that plant. It is, again, 50% larger than the proposed East Brunswick plant. It will serve the waste disposal needs of Westchester County. That's a photograph of the plant taken in October, under construction. Startup is due in late 1984. A more recent photograph winterizing the structure. View of the Bear Mountain Bridge. This is the Hudson River. It's on Charles Point on the Hudson. And that is how the plant will look completed. Bears a strange similarity to what we're proposing in East Brunswick. I touched upon Baltimore, where we are dismantling the pyrolysis project. We placed these bonds, $190 million worth of tax-exempt bonds, 2 weeks ago. That project has been under demolition for about a month and a half now. It will be completed in 1985. It will serve the waste disposal needs of the city of Baltimore and parts of Baltimore County. We have undertaken the responsibility to design, to construct, to own, and to operate the plant. And in that case, have committed over $50 million worth of equity capital to the venture. So in the past 6 months, Wheelabrator Frye has committed over $100 million to the construction of resource recovery plants. We have faith in the technology, we have faith in our ability to run these plants and to benefit the communities that they serve. Which leads me to the final point that I would like to make before turning over the program to our technical consultants. The issue of community benefits. These are the types of things that are associated with a privately developed project, and how would a RESCO project benefit a town like East Brunswick. We believe it will provide a substantial rateable, perhaps nearly the largest rateable in the township. Since the project is basically capital intensive, our costs are fixed up front, we believe that tipping fee stability, unlike what is happening with landfill tipping fees, will be stable. And I can cite as an example our Saugus plant, where in 1975 we opened up with a tipping fee of $13 a ton, and we currently charge municipal customers, according to a contract, $17.59 per ton. It goes without saying that a project representing an investment of nearly $200 million will generate jobs, both during construction, or approximately 1 million man-hours of craft jobs in the building trades, as well as operating jobs and services of local services and suppliers during its operation. These are benefits that are traditionally associated with a privately owned and operated project. There are other benefits that we feel need to be identified and which are appropriate for a host community. There are a number of other benefits that have been developed for host communities in other projects. I cite Peekskill and I can cite Baltimore as 2 examples. There should be greater recognition on the part of the county and of the state for the need to make these plants more attractive in terms of the benefits that they offer to the host community. One major area is in the area of infrastructure development. In a project being developed in the northern part of the state, there are benefits to the host community that go beyond the traditional benefits associated with tax ratables and jobs and services. These are the kinds of benefits which we would like to explore with your leadership, with this steering committee, and with the town as we progress in our application with both state agencies which have cognizance over this project. By that I mean the Department of Environmental Protection and the Bureau of Public Utilities. Both of those agencies hold the final answers on whether projects like this will be built, how they will be built, and under what conditions of benefit they will be considered within the host community. We think we have an excellent opportunity now to work with your town to establish a program which recognizes the contribution that East Brunswick is making in solving the waste disposal crisis facing East Brunswick, facing Middlesex County and the region. It should be recognized by county and state government, and we'd like to work with you and your leadership in to that end. That concludes my comments on our application. I would like to now turn the program over to members of our technical group to talk about some of the details of the process as we have stated it in our updated application and environmental impact statement. The first member of our consulting team is Mark Hepp. Mark is a project engineer with Wheelabrator's Energy Systems Division. He's had intensive involvement with the updating of the Edgeboro-Resco project, is very conversant about areas of combustion technology, and has been a great assist in improving the approach that we've adopted in the current plans. I'd like to turn the program over to Mark, who will talk about the project from the standpoint of an industrial process, a power plant design, how it works, what the combustion cycle is all about, and hopefully we'll progress from there.
Good evening. As Joe mentioned, he basically went over the project itself. I'd like to give you an idea of what takes place inside the building walls of the Wheelabrator Frye system. This first slide shows a general plan of the area, showing Edgeboro Road in the, I guess your far right, where the trucks would then enter both the combined Resco facility as well as the existing Edgeboro landfill. Presently, the trucks going to the landfill are not weighed, and we would keep a much better track of the incoming refuse. There would be a weigh scale up in that area, as well as a recycle center, which we would put in to help the community maintain its recycling efforts. The road shown here would be a private haul road for use of the trucks coming to the plant, with a secondary public road available for visitors and employees to enter and exit the facility. This particular slide shows a cross-section of the plant. I'd like to go through some of the major processing areas and then concentrate a little bit on the boiler and grate, which provide you some of the background as to why this particular technology is working well. The first thing you can notice basically is that the entire process plant is enclosed inside a building, as shown on the renderings, the artist renditions. The entire processing area is all enclosed, so you really won't see anything from the outside. The refuse trucks that would come to the plant would enter in the receiving area, which is a totally enclosed reception hall. There would be a single door for the trucks to enter and leave. And so all the turning movement, the dumping of the refuse into the storage area is all done inside. This helps to minimize any of the noise associated with the trucks, as well as keeps any of the odors or the dust contained within the boundaries of the building. The tipping floor, which is what the trucks ride on to turn around and dump into the pit, is actually sloped towards the pit. Any leaking from trucks, hydraulic fluids, wash down of trucks, all flows into the pit, and it does not escape the confines of the building. A traveling bridge crane picks up the refuse that's stored in this pit and deposits it into a gravity-fed charging hopper, which feeds the furnace with the refuse. Air for the combustion of the refuse is taken from the receiving building. It enters the door and vents, crosses over the pit and into the furnace. By using this air, we essentially keep all the reception area under negative pressure, preventing any odors from escaping, any dust from escaping, and the odors and dust are then incinerated inside the furnace. The reciprocating stoker that the furnace sits on top of maintains a uniform distribution of the refuse and air for optimum combustion. There's a great deal of heat released in the combustion of refuse, and that heat is absorbed in a modern power boiler. The boiler is basically tubes filled with water, and the heat is absorbed and turned into steam. That steam is then used to spin a turbine to generate electricity. The electricity would then be sold to the local utility by means of a electrical line on a typical wooden utility pole. So we would have a connection with the utility on what you would normally see on a street, just a cable on a utility pole. The exhaust steam that would come from the turbine is then condensed by means of a once-through cooling condenser using the river water and the Raritan. The river water essentially only accepts the thermal load from the discharge of the turbine, and the condensed steam is then returned to the boiler for reuse, as is done in a typical power plant. A good percentage of the incoming refuse, about 20%, is non-combustible. It's glass, it's metal, it doesn't burn, and the bulk of this material discharges at the bottom of the furnace and into an ash quench system. This serves to put out any fires, cool the ash, control dust, and is then conveyed to an ash collection pit. The cooled gases that leave the boiler, having given up their heat to the steam in the boiler, are then passed to the air pollution control section of the plant. We've included a spray dryer absorber, which will remove the acid gases contained inside the gas stream. The cleaned gases will then pass through a fabric filter or bag house, where the particulate matter that's entrained in the flue gas, both from the reaction in the spray dryer as well as from the fly ash from the combustion, is then collected. The final gases which are cleaned leave the bag house, the fabric filter, and exit to the atmosphere through a concrete chimney. In addition to the bottom ash, which is discharged from the furnace, there is a great deal of small particulate which is collected both in the fabric filter, the spray dryer, and the hoppers inside the boiler. And this fly ash is jointly conveyed over to the ash pit, sprayed with water for dust control, and combined with the bottom ash. A clamshell crane will then pick up this material and deposit it into trucks for subsequent removal to the Edgeboro landfill. This is a photograph from our plant in Saugus, Massachusetts, showing the inside of the storage pit. Down in this area are the openings where the refuse trucks backed up, dump their load into the pit. And you can see here the grapple crane, this big monster that comes down and picks up the refuse for depositing way up into the upper right-hand corner into the charging hoppers. The pit is entirely reinforced steel concrete structure. It's waterproofed. It's air for the, I mentioned the air for the combustion comes through the reception building, crosses through these openings, across the refuse, and up into the furnace. We typically call this a storage pit. It's probably more applicable to call it a storage bin. This bin would sit below, about 10 feet below the existing ground level at the site and extend upwards over 90 feet. So as opposed to the common thought that this is a big hole in the ground, it's basically a concrete silo used to store the refuse. We have a capacity inside the pit large enough to basically keep us through a weekend. Refuse trucks will stop depositing on Saturday, and we need enough refuse to basically keep us through the weekend till deliveries start again on Monday. I'd like to now concentrate on the processing side of our plant. Other technologies have used shredding and pyrolysis. The only processing we do is to pick it up out of that pit and drop it into the furnace. We do no processing other than to remove bulk, non-combustible material that's obvious inside the pit, and we take that out. I'd like to spend some time on both the lower. This object down here is called a stoker or a grate, in which controls the flow of refuse into the furnace. And this is basically the boiler, composed of both a furnace and heat transfer sections. This is a longitudinal section in the lower part of the furnace showing the grate. Way up here would be the charging hoppers fed by the cranes. The refuse would come down in this area. A hydraulically driven ram feeder would carefully control the flow of refuse onto the grate. The refuse would flow down here and pass through 3 distinct zones on the grate inside the furnace. Combustion air would come through these hoppers underneath the grate to provide sufficient oxygen for the burning of the refuse. In the first zone, we call it the drying zone, the raw refuse is first exposed to the furnace, and any residual moisture is driven off and a combustion is initiated. The middle zone, shown in the yellow, is what we call the combustion zone. This is the part of the furnace or the stoker where the bulk of the combustion takes place. The fire really gets going there, and most of the combustion takes place. The last section, the burnout zone, is basically not too exciting. There's some stubborn material in there that needs a longer period of time to burn, some wood, some tree stumps, logs, that type of stuff. And once that it passes through that zone, it is discharged off the end of the grate, any of the non-combustible portion, and into the ash quench system. Typically, it takes 45 minutes to an hour for refuse to travel from the beginning to the end. Not to bore you with details, but this is a close-up of the grate to give you a better idea of just what's taking place there. The grate is comprised of alternating rows of stationary and reciprocating grate blocks. This chassis dries every other row, and essentially this block would move back and forth, slowly agitating and moving the refuse down the grate. It provides a very uniform movement provides control over the fuel and the air through the grate to provide for the best way we know to control combustion in a very heterogeneous material. This is a close-up of the boiler itself. The grate, which we just went over, is the lower part here, which shows the hoppers and the grate. And to really speak about the boiler, you have to look at it in two ways. One is the combustion side, and the other is the water side, the steam side. To talk about combustion, you really have to go back to there's three fundamental principles of combustion. They're called the 3 T's: time, temperature, and turbulence. And all those have a special application in burning refuse. Time, you need sufficient time in a furnace to be sure that all the material is burned. You got to give it time to the combustible portion to mix with the oxygen so that everything is burned and combustion is complete. We do this in several ways. Basically, we initiate combustion on the grate by providing a great deal of air underneath the refuse. This air, again, is taken from the pit. Odors, dust are sucked in and injected into the furnace for the initial combustion. As the combustion begins and the material heats up, a great deal of gases are given off. Those gases have to be burned. A bulk of the combustion then takes place above the grate. To accommodate this, we have a secondary air system, a system of very unique nozzles and arches that provide essentially the turbulence necessary to complete combustion. The gases are induced to basically a very violent motion in here, to a recirculation of gases to be sure that oxygen is available to any material that has to be burned. And finally, in temperature, this great deal of gas and heat that's released in this area essentially forms a constant ball of fire that sits above the grate at all times. This radiant beam of heat serves to roast and maintain complete combustion of the material in the grate, as well as to combust any of the gases that are given off during the combustion process. The fire is basically complete by the time it leaves the furnace, and the heat that's absorbed in the furnace and the various sections inside the tubes is then used to generate the steam. Briefly, the water enters the boiler in the cold side over here, is sent up to the steam drum, and by proximity to the heat through tubes, the water is turned into steam. The steam, as I mentioned, is then sent to the turbine generator for generation of electricity. At one time, incinerators were very common in the United States. Their basic function was strictly to reduce the volume of the material entering the incinerator. We have a much bigger role in that we're trying to extract every bit of heat we can to recover and to turn that heat into steam for generation of electricity. Finally, in a little bit more detail here, as the gases leave the boiler, they now have to be cleaned up in the air pollution control side of the system. As it passes into the spray dryer absorber, a mixture of water and soda ash is injected into the flue gas stream. This serves to absorb any of the acid gases that are contained in the flue gas stream, and the reaction products, as well as any entrained particulate matter that's inside the flue gas from the combustion, is then conveyed to the fabric filter. We have representatives from our Air Pollution Control Division here, and they'll go in great detail over this particular system that we've applied here to give you just a better feel of how it works. Essentially, we have 62.5 tons per hour entering the furnace, and roughly 20% of that, or 13 tons per hour, is non-combustible and falls off the bottom part of the grate. A smaller amount of material, essentially 3 tons per hour, results from the fly ash and the reaction products in the spray dryer, and is then all combined for ultimate removal to the landfill in trucks. I think that's it.
Mr. Ferrante, I think this is a good time to take just a 1 or 2 minute break while the videotape is changed. Want to do that now? All right, would you be seated, please, so that we can continue with the presentation? We'd like to continue, please. Would you be seated? There's something wrong with the mic, then.
You can have my pencil if you like.
Thank you.
Get him up here. Okay. As I mentioned at the outset, the commitment that we make to resource recovery is not just to design and finance it, but it's to operate it, and operate it for a long period of time. I always have a great deal of pleasure introducing Dan Madigan, because Dan has been with the RESCO project in Saugus since its groundbreaking. He has a wide background in industrial power plant operation and came to RESCO to tame that beast. He's been with us since 1973. He's the key figure in the success of our Saugus operation, and I thought he could come down here and share some of his experiences briefly in what it's like to operate a refuse plant and the kinds of commitments that are necessary to make it work. Dan?
Thank you, Joe. I'll be very brief. My background is that I'm really not as wonderful as Joe thinks I am. I'm an old sailor. I've been firing boilers since I was 17 years old. I had a great interest in the refuse business as a stationary engineer and power plant operator in industry because of the very high cost of fuel is what attracted me, to be basically honest with you. I experienced some difficulty in an industrial plant with a fuel budget that went from $100,000 to $1,700,000 in 11 months back in 1970. I rapidly got interested in alternate energy. That interest took me to RESCO. I've been there since construction started the plant in October of 1975, and since that time the plant has processed 2.5 million tons of refuse, has saved approximately 2.75 million barrels of precious fuel oil, and also has met and exceeded all environmental standards and does to this day. One of the things that is not very often talked about in the refuse to energy business is the people factor. There haven't been very many successes in the United States because there have been many different technologies that haven't been quite what the government and many other people thought they would live up to be. But one of the things that we feel very strongly about is that at Saugus, we have people who are from the private sector and a private undertaking who work with the bottom line in mind and getting the problem solved. With that in mind, I'll show you some slides of the plant. If you turn the lights down, please. This is a view of the Saugus plant. You have to remember that this is the first plant that Wheelabrator did, the very first successful plant in the United States as well. And I don't think we'd get any award for aesthetics or architecture. I understand that all the future ones will get awards or somebody will be looking for a job. That's an overview of Saugus anyhow. And here's a few facts about the plant. As I said earlier, we service 18 communities in 3 states. Primarily, we serve the metropolitan Boston area, the North Shore area of Boston, and we service 1 community in New Hampshire and 1 in Maine. We serve approximately 750,000 to 800,000 people. These figures are old. The 2.5 million is as of January 1st this year. Steam sold is now 15.2 billion pounds to the customer. Oil equivalent is, that's in gallons, but that in barrels, that would be about 2.75 million. Ferrous metals, that is the actual number, and it hasn't changed very much, to be perfectly honest with you, because the metal market has been pretty bad in our present economy. Very little movement in the last 18 months, only marginal sales in that area. This is a picture of the control room. This is Howie Brown, one of my boiler operators. He's been with us since 1975. And all I could say about this is that it's a very conventional control room, and conventional in the sense that we run RESCO just as any utility or large industrial power generator would run a conventional power plant. We have feed water regulators, feed water requirements, air requirements for combustion, and fuel-air ratio controls. And I might add that the plant is fully automated and operates automatically. It's only put on manual for problems or emergencies. In talking about the people in the plant, I'd also like to add that what Wheelabrator has and what we have as a company is 8 years of experience, operating experience, with our own name on the front door. We were responsible for the design, the construction, and the operation. So therefore, we can't say, well, we did a good job building the place, they just didn't know how to run it. If it's not run properly, it's our fault, no one else's. And I think we can offer that, and with that, we can offer you experienced people, people that are available, that understand the business, and will make great contributions to any future endeavors that we undertake. Right to the point that every one of our employees is involved on a regular basis in technical updates, month-to-month operating needs, any inputs that any employee has, regardless of his position in the company, are asked for, recorded, documented, and his assistance is also used in the implementation of things that we accept as changes to the design and improvements in efficiency. For instance, a little sidelight, we just did a very extensive wastewater study at Saugus after 7 years of operation. Spent approximately $26,000 to just review our existing waste streams and see what we could do to improve things and improve our efficiencies. One of the things that we have in our plan is a little trickle of water that we put into the refuse for control of clinkers in the sidewall of the boilers. This is a very innovative thing. You talk about these large companies with all these great technologies. This happens to be called the Willie water, because a guy named Willie Taylor, who works for me, decided that that would work, and we tried it, and it works very well. And after realizing that it works, our engineers told us why, so we're pleased with them as well. But in doing the survey, the formal survey was done by Schneider Engineering Consultants out of Pittsburgh. The Willie water is referenced in the text in about 7 or 8 different places. And so Willie has become quite prominent, and perhaps Willie water will be utilized in the industry in the future. As a matter of fact, this gentleman right here, that's Willie, the shift supervisor. The little fellow there is a fellow named Manny D'Souza. Manny is the labor foreman. And the reality of this business is, without a labor foreman in a plant like ours, I guess we'd have to go out of business, because he is responsible for everything. He's the lowest paid guy in supervision. He has to take care of the snow, the parking lot, the flowers, the lawn, the executives' cars when they come to visit, and all the visitors. And everything he does is wrong, and even if he didn't do it, we blame him. So he probably has the worst job in the plant. I see that Willie is complaining about some refractory in the boiler, because Manny takes care of that as well. And along with that, I'd like to just say that the plant from our own experiences, requires a group of people that have to be fairly sophisticated professionals and technicians. Primarily, we employ stationary engineers. Here in New Jersey, you have a license law, which is very similar to the law in Massachusetts, that categorizes various needs, various licenses and grades according to the horsepower of the plant. That requirement would carry right over to Edgeboro. So the nucleus of our people are either ex-utility employees or young people that we trained and brought up through the ranks, or ex-sailors or merchant seamen. The license grades in Massachusetts are also very similar to those for licensing of merchant marines by the Coast Guard. So that's the primary guy that we use in the plant, utility type worker, and then we use conventional maintenance crafts, pipe fitters, steam fitters, millwrights, welders, electricians, and so forth. And then again, Manny, as I said, does everything and takes care of the whole thing. We also have an office staff and some technical people for feed water control and testing, traffic controllers controlling the refuse trucks, and naturally scale operators. So that pretty much tells you what the real world of operations is, and I think we can say very frankly that we're probably the only company that can sit up here and tell you, yes, we know how to operate a plant, we make a buck at it, and do it very well. The other thing that I can say is that there's been an awful lot of research and development conducted at Saugus, and every bit of it has enhanced development of future installations, such as Westchester, Baltimore, and we've even employed things in the design of Edgeboro, things that we have learned and have studied at Saugus. We have done approximately $200,000 worth of research just in monitoring the combustion zones in the furnace chamber. We have done research in air pollution control, monitoring of gases leaving the plant. We have looked into every single significant area. My understanding of this job is just to briefly tell you what the history at Saugus has been relative to basic particulate as far as pollution is concerned. The federal standard in the United States is 0.08 grains per standard cubic foot per million BTU fired. The Massachusetts state standard is 0.05. The actual operating history at Saugus over the past 8 years, involving extensive tests between 18 and 24 formal stack tests at Saugus, says that we run at about 0.02 to 0.025. My understanding is that here at Edgeboro we are designing for 0.015, the New Jersey standard being 0.03. I have no problems with meeting 0.015. We have at Saugus an experimental fabric filter, as you saw in the schematic earlier that Mark showed you, that we will have a fabric filter at Edgeboro. Saugus has an electrostatic precipitator. We'll also have a spray dryer at Edgeboro. The fabric filter at Saugus has been with us since 1977. It's a pilot unit. We've invested $500,000 in it. It only handles 4,000 ACFM, which is minute compared to what the plant requires. But that filter, we have done everything imaginable to test it, prove it, and fully understand it. To take it a step further, in April we're going into a further R&D program in that area. We're going to look at electrostatic fabric filtration, which we hope in the future will be a consideration. But what we know to this day about fabric filters is, at least what I know, is that it's very hard to destroy one, because I've attempted to do that for the past several years. So those are some of the things that we have learned, and that we know what the needs are in the United States, and what we have to do to accommodate the communities and accommodate the needs in the environment. Wheelabrator is into environmental sciences. This is what we do. We sell environmental control devices, and we certainly want to continue to be the leaders in that area. Thank you very much.
Thanks, Dan. So far, we've looked at the plant as a design entity and as an operating unit, and now we're going to take a look at how it functions in the environment. To do this, we retain the services of a number of consultants to help us complete the environmental impact statement. One of them, Professor Nathan Rees from Rutgers University, was responsible for coordinating the effort in analyzing plant emissions and relating those to our choice of air pollution control technology, the best available air pollution control technology issue. Professor Reese is a professor of meteorology at Rutgers University, and he'll be with us tonight to describe the results of his studies. Matt?
Thanks, Joe. My primary role in this project up to now has been to prepare the air quality portion of what is known as the best available control technology, or BACT analysis. This is a study which is mandated by the federal government, the purpose of which is to determine what the air quality impact of the plant would be under different combinations of air pollution control scenarios. Specifically, in this case, we wanted to examine the relative impact of 3 different stack heights, namely 230 feet, 300 feet, and 380 feet, as well as that of 4 different types of air pollution control technologies. The first being an electrostatic precipitator operating alone, that is, the plant connected to nothing else but an electrostatic precipitator. Secondly, an electrostatic precipitator operating in combination with a wet scrubber. Third, an electrostatic precipitator operated in combination with a spray dryer absorber. And fourth, a fabric filter operated in combination with a spray dryer absorber. The last of these combinations, the 2 last combinations that I mentioned, were assumed to produce identical emissions to the atmosphere, and we treated those as one single case. So in effect, we had 3 different air pollution control technologies and 3 different stack height combinations to model for a total of 3 times 3, or 9 different scenarios that we modeled for. Now, the means that we use to investigate these various combinations is a mathematical air pollution dispersion model. Now, obviously, I'm sure a lot of you are very suspicious of models. Obviously, if you choose a model to suit your purposes, you can prove almost anything you want. And for that reason, the EPA is very particular as to what type of model you use in a study such as this. They have a series of models, which they call recommended models, that have been tried and tested, and they've been shown to produce reasonable results when used under the particular set of circumstances for which they're designed. The model that we used here is a so-called ISC, or Industrial Source Complex model, which is one of the most sophisticated models currently available. The model is used specifically for simulating the behavior of a hot plume that comes out of a stack, particularly in the vicinity of some sort of a structure. And it basically describes what the plume does when it comes out of the stack. I just wanted to refer to the blackboard here for just a minute. I don't know if you'll be able to see it. Just be a few seconds. Basically, what the model does is it models the rise of the plume when it comes out of the stack. The plume does not move straight horizontally when it comes out of the stack. There are 2 things that make it rise. First of all, the plume has a certain amount of buoyancy because it's very hot. And it also has a certain vertical velocity when it comes out of the stack, which is impelled to it before it came out of the stack. It has an upward motion before it even starts out. And the model models the behavior of the plume when it comes out, and then it models the dispersion of that plume by the wind after it rises. In fact, it even models the behavior of the plume as it's in the process of rising from the stack up to its final elevation. In addition, if you have a situation where there's a building near the plume, as is the case here, this model also describes the effect of what we call building downwash, where turbulent air currents around the building will cause the parts of the plume possibly to be sucked downward. So this is a very sophisticated model. Before I discuss the results of the modeling, I just want to briefly explain the effects of the 3 control technologies that we considered. And some of these have been touched on already. I just want to kind of put it in perspective. The purpose of the precipitator or the fabric filter is to essentially eliminate the emission of particles from the stack. These are the kinds of particles that would cause a plume to appear brown or black when it comes out of the stack. Now, this kind of thing is definitely illegal in New Jersey, and you just don't see plumes like that around anymore. All of the scenarios that we looked at employ either electrostatic precipitators or fabric filters. The purpose of the wet scrubber or spray dryer absorber is to reduce the emission of acid gases, principally in this case hydrogen chloride, hydrogen fluoride, and various oxides of sulfur. Both types of scrubbers, both the wet scrubber and the spray dryer absorber, produce about the same amount of scrubbing action. They reduce the hydrogen chloride and hydrogen fluoride emissions by a factor of 10, and they reduce the oxides of sulfur emissions by a factor of about 3.33. The emissions of other pollutants are essentially unaffected by the scrubbers. The scrubbers have other effects, though, besides cutting out the acid gases. They moisten the plume, thereby causing it to cool off and become less buoyant. And this has an impact on how high above the stack the plume will eventually rise. If the plume is not too hot, it won't be as buoyant, it won't rise as high, it'll be down closer to the ground. The scrubbers also slow down the plume's vertical velocity as it leaves the stack, thereby giving the plume another reason to be down closer to the ground. So with the scrubbers, you get a plume that has less acid gases, but it's also a plume which is down closer to the ground for a given stack height. This causes the concentrations of the unscrubbed gases to be somewhat higher than they would be for the same stack height without a scrubber. The wet scrubber tends to moisten the plume more than the dry scrubber does, while producing no additional scrubbing action. So from a purely air quality standpoint, the wet scrubber would seem never to be preferred over the spray dryer absorber. It doesn't do anything for you, and it gives you a lower plume. On the other hand, the wet scrubber is less expensive than the spray dryer absorber. That's not my field. The effect of raising the stack height is to allow the plume to disperse more before it reaches the ground. And I just want to give you an idea of that. If this is the ground, and you have a plume up at, traveling along up at this level, the plume will disperse something like this, and eventually it'll intersect the ground somewhere back here. If the plume were emitted at a height down closer to the ground, it would do the same thing, and it would intersect the ground at a closer location to the stack. Of course, the closer the location to the stack where it intersects the ground, the less of a chance the plume has to disperse. So you like to have a taller stack in order to give the plume more chance to disperse outward. The effect of raising the stack height, for example, if you go from a 230-foot stack, which was the lowest stack height that we modeled, to a 380-foot stack, which was the tallest height, that kind of a change reduces the maximum ground level concentrations that would be observed by a factor of from about 5 to 8. And it moves the location of that maximum ground level concentration outward from a distance of about 1/4 of a mile from the stack for the 230-foot stack to 2 miles from the stack for the 380-foot stack. So when it comes to choosing where to put one's resources in choosing an air pollution control technology, one can choose a short stack with a scrubber or a tall stack with no scrubber. In the first case, with the short stack and a scrubber, you get lower acid gas concentrations, but higher concentrations of everything else. With a tall stack, the overall concentrations will be lower, but there'll be no particular control on the acid gases, and those concentrations will be somewhat higher than if a scrubber were used. Of course, one could have both the scrubber and the tall stack, but the expenditure would be much larger to have both of those things. Getting back to the modeling, as a result of the modeling, we determined that it's possible for the proposed facility to meet all existing federal and state air quality standards when operated with a spray dryer absorber in combination with a fabric filter and a 230-foot stack. I should mention in this regard that the emission rates that we used in the calculations, which are critical to the calculations, were extremely conservative. In some cases, the values that we used for safety purposes were a factor of 5 to 10 higher than what would actually be the case. Can you turn down the lights now, please? Okay. The three most significant emissions in terms of their impact on the standards are sulfur dioxide, oxides of nitrogen, and lead. And this slide graphically shows how the concentrations would relate to the standards. And these would be the maximum ground level concentrations that would be produced by the RESCO plant, and these are the standards. I emphasize that these are the maximum ground level concentrations that would be observed anywhere. Everywhere else other than that maximum point, the concentrations would be even lower than that. The standards are for the standards that the federal and state governments have are couched in different terms for different pollutants. So for sulfur dioxide and nitrogen oxides, we're looking at an annual standard, and for lead, we're looking at a 3-month standard. There is at the present time no federal or state standard for hydrogen chloride, but the state is contemplating setting such a standard. But from this slide, you can see that the world's most stringent standards, there are many countries that do have very stringent standards, and the RESCO plant would be in compliance with even the most stringent standards now in effect anywhere in the world. And it would certainly be very far below the levels that would cause any sort of odor or any sort of leaf damage. The emissions of other pollutants and their ground level concentration, pollutants I haven't mentioned here, would be even less significant than these in terms of their impact. These are the 3 most significant ones. To summarize, based on the BACT analysis, we've ascertained that the facility operated with a 230-foot stack in conjunction with a spray dryer absorber and fabric filter would operate well within all existing health-based pollutant standards. Thank you.
To complement Professor Reese's examination of the effect that the proposed facility would have on air quality, we asked other technical advisors to look at other environmental issues associated with the plant. We asked Ware & Engineering, who coordinated the environmental impact effort, to look at the site geology, to look at issues concerning water consumption, ash disposal, traffic, and the use of the river as a condenser cooling water medium. I want to introduce from Ware & Engineering Dennis Fenn, who is their Senior Vice President and who was in charge of that effort. Dennis?
Thank you, Joe. As was previously stated, our role in the project was to focus on the preparation and completion of the environmental impact statement. This involved not only our in-house studies on the various aspects of the project, but we worked very closely with the technical engineering staff at Wheelabrator Frye, as well as, of course, with Professor Reese relative to the air pollution control technologies. We prepared the environmental impact statement in response to the guidelines and requirements established by the New Jersey Department of Environmental Protection. The department has established such guidelines specifically for solid waste disposal facilities, including landfills and the like, and more specifically has modified those guidelines for resource recovery facilities. Basically, what's involved in the scope of the environmental impact statement, well, first of all, when you initiate such a program, we've spent extensive amount of time with the department and their technical staff, reviewing their guidelines and requirements, preparing a detailed scope for this particular project. And basically the scope encompasses, first of all, a detailed description of the environment of the proposed project. Secondly, projections are made as to the characteristics and potential impacts that the project will have on the particular environment. And lastly, the impact statement must address mitigation methods for those potential impacts, as well as alternatives that should be considered. Tonight, we were going to focus on the 4 specific areas mentioned by Joe, which were also brought up by the steering committee. These do include possible impacts on groundwaters in the area, ash disposal, traffic, and effects on the surface water, principally focusing on the thermal effects on the Raritan River, in that the facility does not have any wastewater discharges. First of all, relative to the siting of the facility on the Edgeboro property, we had several criteria in mind. Here we see a cross-section, a geologic cross-section through the facility area. Basically, this cut runs north and south, perpendicular to the river, with the so-called Clancy's Island to the left on the slide, which is a higher topographical area, into a lower topography area, which is virgin ground, back up onto previously landfilled area, and beyond the edge of the slide would be the Raritan River. The physical plant location is in this general area on the lower topo existing ground. Basically, of key concern in orienting the plant here was distance to a bedrock formation which would serve as a bearing soil for the foundations, because it is a major structure, as well as having heavy equipment. And secondarily, considering a potential effect on groundwaters. The physical plant itself really does not have any effect on groundwaters. As was previously described by Mark Hepp, it is literally an industrial plant. The surrounding areas are paved. All the handling and manipulation of refuse itself occurs within the confines of a building, on top of structural concrete and sealed tipping floors and pits. So there's really no leachate potential from the physical plant itself. Also, relative to the existence of any water-bearing, potable water-bearing zone directly under the physical plant, there is none. Relative to the residue disposal, which, as was mentioned earlier, all of the residue will be taken to the adjacent Edgeboro Sanitary landfill. That landfill, of course, is permitted. It has a complete leachate collection and control system, much of which is under construction presently, and will totally isolate the residue area from any potential impacts on the groundwaters of the region. Relative to the potential leachates from the residue of the Resco plant itself, this slide depicts, let's say, a comparison between a leachate from a raw municipal solid waste as it would be disposed of in a sanitary landfill, and a leachate from an ash from a Resco facility. As many of you are probably familiar, raw municipal landfill waste by its very nature and by the nature of a landfill operation, produces leachate. It's a fact of life. That's the motive for a lot of the environmental regulations the landfills are facing today. In this case, and it's been well documented in the literature, landfill leachates tend to be acidic and tend to carry metals and other contaminants in solution. In the case of the Edgeboro Sanitary Landfill, they thereby are controlling that with their leachate collection system. The ash from the RESCO facility is typically alkaline, and in the case of the proposed Edgeboro plant, it will be even more alkaline with the use of the soda ash spray dryer air pollution control equipment, which raises the alkalinity, thereby tending to keeping metals and other contaminants in a less soluble condition. And although it does create a leachate, it's a less benign leachate than you would find in a raw municipal solid waste leachate. The conclusion being that the leachate control system in the Edgeboro Sanitary Landfill would be more than adequate for our leachate. What about other water requirements at the facility? The process requires other waters other than the Raritan River cooling water system, which will be described in a little bit more detail in a moment. These waters include the water necessary for the operation of the spray dryer itself, which represents, as you can see on this graph, a large portion of these other processed waters, roughly 70%. It will roughly use in the neighborhood of 108 gallons per minute of water. The discharge from this is basically through the stack as vapor. There are other less significant water uses in terms of process services such as boiler blowdown and other miscellaneous uses in the plant. There are representing about 22 gallons per minute. Also exits the stack as vapor. The bottom ash quench waters, which exits the plant basically in the residue. And then there are some very minor uses for fly ash conditioner and the basic sanitary needs of the employees in the facility, which would be discharged to the sewer system, municipal sewer system. Those represent roughly a total of 4 gallons per minute, a very small amount. This total processed water need would reflect approximately 157 gallons per minute, or about 220 or so thousand gallons per day, and would be drawn from the on-site well at the Edgeboro landfill, which has a permitted capacity of well over 7 times that amount. Now we want to get into the other 2 impacts, that being traffic, focusing on the analysis we conducted at the intersection of Edgeboro Road with Route 18 and Old Bridge Turnpike, and the thermal water diffusion system in the Raritan River used for cooling the condenser. I'd like to introduce Gary McEntee from our office, who has served as senior scientist and manager of those studies, for a brief explanation of the same.
Thank you, Dennis. As Dennis has mentioned, in preparing an environmental impact statement, there are many separate technical studies that are performed to address the environmental concerns. Could we dim the lights a little bit? Thank you. One of these studies that was conducted was a traffic analysis study to assess the potential impact upon the roadway systems in the area. First of all, let's identify some of the roadways here. We have Route 18, Edgeboro Road, which is the main access to the site, of course, Old Bridge Turnpike. In conducting a traffic analysis study, the first initial step is to actually go out and see what is existing. Thank you. Okay. What is existing as far as roadway conditions? First of all, we look at roadway geometrics, measuring the side of the various access points to the facility. The other thing we want to look at is existing traffic along that roadway system. In doing that, we undergo a technical study of the various turning movements throughout each of these access alternatives to the facility. In doing this, we actually located the various turning movements of other vehicles through this intersection. The first one would be cars, refuse vehicles, and then trucks in general. Once that has been completed, we tend to look for the peak hour that vehicles will be going through this intersection. In determining the peak hour, once determined the peak hour, we can then do a capacity analysis. In looking at our study, we've determined that the peak hour traffic flow through this intersection is between 7:30 and 8:30 in the morning. There's also a corresponding peak hour in the evening between 4:45 and 5:45. However, for our analysis of this facility, we're mostly concerned with the AM peak hour. Looking at this peak hour, basically through this intersection, there are 4,800 vehicles that actually move through this intersection between Edgeboro Road and Route 18. Of those 4,800 vehicles, approximately 93 are refuse vehicles presently going into the site. When speaking about the 93 vehicles, we must remember that those 93 vehicles, there's actually only approximately 47 vehicles that are being counted. However, we're counting the vehicles entering the facility as well as exiting. Okay? That 93 vehicle trips represents only 2% of the total traffic moving through this intersection. Okay, so during the peak hour, which is the most critical hour in assessing safety analysis, capacity of an intersection, we only have 2% of that vehicle traffic being refuse trucks right now. Okay? This low amount of refuse trucks coming through the intersection is quite typical of solid waste facilities in general. Basically, at any solid waste facility, whether it's a landfill or resource recovery facility, you have 3 peak hours of delivery of refuse to the facility. Okay? We have a very early morning peak between 6 and 7 o'clock in the morning. We have a late morning peak between 10:30 and 11:30, and then an early afternoon peak probably between the hours of 1:30 and 3 o'clock. What we have here is the peak delivery to the facility, as far as refuse vehicles, straddles the peak hour of vehicle traffic through this intersection. Okay, so the majority of the waste that's coming in will either be coming in before we have our peak hour or after. Okay, therefore, the refuse vehicles themselves do not have a major impact on this peak hour. Okay? I understand what you're saying, but what I'm trying to present here is that during the peak hour, which is most critical to a capacity analysis, trying to determine the level of activity on a roadway, you must look at the peak hour for all traffic coming through this intersection. And at this hour, we only have 2% of refuse vehicles. Okay? Okay, well, we can discuss this in the question and answer period.
Please, we'd like to get done with the presentation. You'll have an opportunity. You'll have an opportunity when we're done to speak.
Okay. In looking at this, okay, fine. Well, first of all, let's continue with what we've tried to do as far as projecting impact, okay? This roadway system was evaluated in 1985 by growing up molecular traffic along this roadway, okay? Taking those numbers, we have superimposed the amount of refuse vehicles that enter the facility. We have the same type of distribution, where the refuse vehicles will be entering early in the morning, again later in the morning, and then early afternoon, showing the same type of pattern, okay? Therefore, showing to us that the actual refuse vehicles entering the facility does not have a major impact on that peak hour turning movements, okay? The other study of much concern that was addressed was the cooling water study, which we'll turn to now. Let's identify the site, first of all. This is the site of the resource recovery facility. As Mark mentioned before, the Raritan River will be used as a cooling water source. Both the water will be taken from the Raritan River, will be run through the system here, used as cooling water, and we discharge to the river at an elevated temperature. Okay? So basically what we have is an intake structure here, for this most upstream portion of the site, Okay, this intake structure, of course, will have the best available technology to minimize any type of impingement of fish or larvae upon the screens. And then we'll have a discharge structure here with a stage-type diffuser. And basically what a stage-type diffuser is the ports are arranged so that the actual discharge of the water is directed towards the surface to maximize the heat exchange between this diffused water and the surface. If we can go to our next slide here. Okay. Once looking at a once-through cooling system, okay, one of the major concerns is evaluating the criteria that are set forth by New Jersey Department of Environmental Protection. Okay. Before the actual once-through cooling system was decided upon, we looked at various alternatives for cooling water use. In fact, in the earlier submission, we looked at 4 different cooling water alternatives. These cooling water alternatives were a cooling tower, spray cooling, a cooling pond, and the once-through cooling. Based upon comments received both from the county and the state, the once-through cooling was the most feasible, both economically and environmentally. Okay. Once we decided upon we'd like to use the once-through cooling, we met with New Jersey Department of Environmental Protection. Okay. In meeting with them, we reviewed their regulations, okay, the type of model we were going to use to assess this potential environmental concern, as well as to ask them for any input as far as data, other facilities discharging into the waterways, and so forth. Okay. Once sitting with them, we went over our model, and presenting our model, they felt very confident that the model we were using would be able to give them the results that they were looking for and give us an adequate evaluation of the concerns. If we look here, New Jersey has regulations that limit what's referred to as the mixing zone for thermal discharges. If I can just jump to the next slide for a little bit. Mixing zone basically would be this area for the state. The state has set up this area as 150 feet across. Okay? What the state wants to maintain is that this area will be allowed for mixing of the discharged water. At no point can the water outside the circle be increased more than 1.5 degrees Fahrenheit. Okay? It's a fairly stringent regulation. In looking at these criteria, we conducted a thorough modeling analysis. Let me just jump back here a second. Okay. Again, this is the criteria that the state has set to ensure that there will be no impact upon aquatic organisms within the river from a thermal discharge. As you can see, major criteria here, surface width, 150 feet. The results from our study, we're going to state again, is 48 feet, well below their regulation. The cross-sectional area, which if you took a cross-sectional area of the river, okay, would be 25% of that cross-sectional area. Again, our studies show that would be 14%. Both this criteria and this criteria are very important in assessing potential impacts to fish, especially migratory fish. What you must maintain within the river is a zone of passage. So any type of migratory fish can pass through the river and not be impeded by the actual thermal discharge. Okay? And again, the final criteria is at no time shall the waters outside of that mixing zone be more than 85 degrees. And again, showing our calculations, the maximum during the hottest summer days would be 83. I think we can really see the comparison. We jump back to the first, sorry, let's go forward too. Jump back to the first slide. And taking an aerial view of our discharge, we have the state-regulated mixing zone, which is 150 feet. As you can try to get a picture of what this looks like in the river, from shore to shore at mean low water is 450 feet. Therefore, this 150 feet that they allow is 1/3 of this area across. In our calculations, we show well below that 48 feet. Okay, so in summarizing our diffuser study in meeting with the state, we feel that by falling so far below the requirements of the discharge, that this discharge itself will not impede any kind of movement within the river of any fish, nor will have any kind of serious impact upon other aquatic organisms. Thank you. Joe?
Our final speaker is Peter Mernon, who is a senior scientist with our Air Pollution Control Division. And I asked Peter to come down here because I think it's important that you have a thorough understanding of the control technology that we're proposing on this plant, the combination spray dryer fabric filter. We've had extensive experience in using these technologies. We want to share with you how they operate. And I've asked Pete to come down and give us some brief statement on that.
Most of the information you heard has been specific to the project in terms of the details and the numbers and so forth. I thought what I might do is talk a little bit about the evaluation of the equipment and why the choice of a spray dryer fabric filter is particularly well suited to the requirements that are needed at the proposed Edgeboro facility. Wheelabrator as an organization has a number of divisions involved in air pollution control, a number that are dealing with wet flue gas desulfurization, wet gaseous cleanup systems for fossil fuel fired utility and industrial boilers. The air pollution control division that I'm involved with is primarily involved in a couple different types of particulate control, the ash control, as well as the dry scrubbing system that was mentioned as part of the design. There are a variety of fabric filters that can be chosen, as well as the electrostatic precipitator, which was mentioned earlier. And I think most germane here, the dry flue gas desulfurization system. The experience that Wheelabrator has in dry scrubbing really dates back to the late 60s, where here we were looking at a fabric filter in combination with a reagent to provide absorption of various gaseous species. But most importantly, in the mid-70s, the work on the two-stage SO2 and HCl removal studies, which involve gaseous emission removal both in the spray dryer and in the fabric filter, as well as particulate removal in the fabric filter. We're involved in 4 applications of systems of this type, ranging in size up to 2 million CFM, or approximately 10 times the size of each of the systems that we'd be seeing here at Edgeboro. The types of additive, the level of activity, the operating experience, on some of them go back to January of 1980 on an industrial application and March of '81 on a large utility installation. In its simplest form, the system has 3 basic parts. One is an additive preparation, in this case the storage and dissolution of a soda ash solution, and soda ash is really a sodium carbonate, not unlike a sodium bicarbonate baking soda type material. The second part is the spray dryer, where the gas is brought into contact with the solution of soda ash and water. This provides for 2 things: absorption of the HCl and SO2 by the liquid droplets with the additive, which subsequently react and neutralize with them. And also, as the flue gas travels down through the spray dryer, we accomplish the second important phase, which gives the process its entire name, namely the drying of this product. So when the gas and particulate excuse me, reach the bottom, we have a dry material for disposal, just as we do with the ash from the fabric filter. The flue gas then continues on to the fabric filter, where we get residual removal of SO2 and HCl, as well as the full particulate removal. A couple points are worth noting here in contrasting this with experience with these types of systems. In total, there are some 15 large utility installations, and these units would typically be measured in the millions of CFM range, compared to the total flow here at Edgeboro of about 340,000 CFM. There are also about 10 industrial applications. As I mentioned, we're involved in a total of 4 in the utility and industrial area. This represents a unit that we're currently starting up outside of Atlanta, Georgia. It's about 110,000 CFM, or about 2/3 the size of what one of the spray dryers would be at Edgeboro. Other thing worth mentioning is that the technology of spray drying itself is actually been around for quite a number of years. In fact, some 50 years that spray dryers have been used for drying pharmaceuticals and foodstuffs and a host of other chemical and processed materials. What we've done here is to add a material to it that reacts with the gaseous species that we wish to remove. Wheelabrator is fortunate also in that regard, and the two divisions, Nichols Research and Engineering, located in Belmead, New Jersey, has over 100 installations of generic spray drying systems, as well as the Swenson division of Wheelabrator, which has some 120 applications of pressurized nozzle dryers. So the technology is, I think, is there. The experience that we've had both in dry FGD and the other background is what gives us the confidence in the design. In a little more detail, the spray dryer itself is a vessel with perhaps 10 or 12 nozzles that atomize the solution of material that will serve to remove the gaseous constituents. The liquid is added compressed air. What this does is to create a finely divided cloud of spray droplets, which enhances the removal efficiency. This shows one of several nozzles that would be in the spray dryer, and we're contacting the liquid and gas by providing coverage of the plant area so that the gas flows through the spray pattern, as well as the pumping action which occurs as the gas is drawn down into the spray pattern itself. Even here I might mention there are a couple of choices that we had available to us. This is referred to as a rotary atomizer dryer, which accomplishes atomization by spinning the liquid off a high-speed rotating disc, perhaps spinning at some 15 to 20,000 RPM, being driven by a 600 or 800 horsepower motor, which would be the size required for the edge burrow application. What we've chosen, however, is the two-fluid nozzle dryer, which, as I mentioned, we have one system in operation and the other just starting into the design phases. These achieve comparable performances. This is the type that one would see in a large utility application where, for some technical and economic reasons, you can basically get more energy-efficient atomization in the multi-million CFM range using this approach. Here what we're doing is taking an approach of an incredibly simple system. It's a nozzle not unlike your shower head. It has no moving parts. The material, the nozzles can be inspected and removed while the unit is in operation. What this means is that you have overall greater reliability, maintainability of the system, which speaks to the fact that you have even greater assurance of maintaining your emission requirements. The other major area is the fabric filter, as it does provide us with additional gaseous pollutant removal and with our particulate removal. The way a fabric filter works is basically it's not unlike the analogy of it being a large vacuum cleaner is appropriate. We have a bag made of cloth through which the particulate-laden flue gas passes. As the gas passes through the cloth, the particulate matter is filtered out. In its simplest form, that's what it is. But like anything else, there are a number of subtle variations. In addition to the basically in the type of cleaning method itself, there's two predominant types that would be suitable for this application. Again, we're talking about equipment that has been around for 70-some years. One is referred to as reverse air, and the other, the type that we've proposed, is shake and deflate. They differ in the manner that one uses to remove that entrained material from the fabric filter itself. It's only half the job to collect it. The other half is to then transport it out of the system. The advantage that shake and deflate has is that instead of just blowing gas back through the bag to force the collected material off the filter, what it does is blows a small amount of gas back through the bag to relax it, and then provides a gentle mechanical shaking action to the bag, which actually causes waveforms to ripple down throughout the length of the bag, which provides uniform and complete removal of the collected material. One thing that might mention that we did here, in addition to the 015 emission levels, and this is, I think, well verified in the literature that certainly in comparison to a precipitator, we're looking at improved collection of not only in terms of the absolute emission rate, but also collection in the very small particle size range. I think it's pretty well documented that below the overall removal efficiency on edgeboro will be about 99.6, 99.7% of the incoming particulate. Fabric filter would have about 99.5% removal efficiency on particles less than 10 microns.
May I stop you right there while we do some work on the video system?
Sure.
And would you please remain seated? This will just take a minute to change over.
Okay. And again, one final point in the collection and control using a fabric filter is that it's a multi-compartment installation, and what we actually do is during this cleaning cycle we remove that compartment from active service so that we have no chance of re-entraining the particulate matter that we've already collected. This shows 2 of what would be 8 compartments on the for a unit the size of Edgeboro. This first compartment shows the fabric filter in operation. Dirty gas comes in through the inlet plenum, turns where some of the larger particles fall out, passes up through the fabric filter cloth. Fabric filter, the gas passing through the fabric filters out the particulate. The clean gas then goes on and to the outlet plenum and onto the fan and stack. When it's time to clean a unit, which is initiated by a combination of pressure drop across the bag house, as well as backed up by a timing cycle, the dampers would close, isolate this compartment, and by isolate I mean no gas flow would be going through it. We then go through the cleaning cycle I described before. A gentle amount of reverse air to relax the bags, and then the mechanical shaking action to provide uniform removal of the filter cake. And the system was, of course, designed to, even though it has 8 modules, that it would normally function with 7 of those modules in service, requiring one, allowing one to be offline for cleaning. And in fact, we've gone even one step further in that we not only have sized the system so that we can have a module offline for continuous cleaning, should that be required, but also we have a module offline for maintenance. And again, as with the spray dryer, these compartments, these 8 compartments, are maintainable online. You would isolate it, open the door to provide ventilation and cooling, and then be able to go in and inspect, repair whatever work might have to be done. This shows a large unit with under the construction phase with the filter bags themselves being installed. Although this is for a larger utility application, the specifics for Edgeboro would be something like 8 compartments with about 240 of these bags in each compartment, about 8 inches in diameter, some 22 feet long. What you see down the bottom here is referred to as the tube sheet. These bags are hollow. It's fastened at the bottom, and the dirty gas comes up through these holes and then passes through the bag and on out the top. The way they're installed is it's clamped onto the bottom. This man is pulling it up to the top where it's aligned on these hooks, and these hooks in turn go across to a tubular member which is hooked to a motor, which is what provides the rotation and the shaking action on the bag. As you can see, the modules are generously sized with walkways and spaces so that there's room to go in there and to individually change any given bag that might have a hole or be a problem. Might also mention in passing that the way the system is monitored, because we are looking at very low particulate loadings of 0.15, it's primarily monitored with an opacity meter. Just as we have SO2 meters to monitor the SO2 and HCl, we have opacity meters to monitor the particulate matter. And basically, the opacity is a measure of the light reflectance, and should a bag come off, there would be a jump in the particulate loading, which would identify the fact that repair, maintenance, inspection is needed. You would go in, look around, and because you're talking about this being on the clean side of the bags, one would look for little mounds of dust, other obvious dislocations of the fabric itself. Just give you a further perspective on what the fabric filter is doing. This is one of the units that we have. This is a model of the unit at a large utility application. This is one of 38 modules, and we have a total of close to 8,000 bags there. Roughly in terms of number of bags, about 5 times the size of what would be required for Edgeboro. Here we see the relative to demand. This was what we saw before, the tube sheet, and this shows the given compartment and the inlet and outlet areas for gas flow. So then these are isolated and provide ease of maintenance. That concluded what I wanted to talk about on the general side of the equipment.
All right, thank you. First of all, before we go any further, can you hear me? Yes. Good. Thank you for your patience, and thank you, gentlemen, for your presentation. Since the presentation took a lot longer than I expected, I'm going to depart from our planned procedure, and I'm going to turn the meeting over to the public to ask questions of the applicant. Before I do, though, I'd like to repeat something I said at the outset. This is certainly not the last time that you'll have an opportunity to ask questions. It's not the last time you'll have an opportunity to tell us what your concerns are. And it's not the last time you'll have an opportunity to give us information you think we might not otherwise have. Because of that, and in fairness to everyone who's here, I'd ask you to limit yourself to questions, not to make speeches. If you have something to present to us in the way of information, we can get it at some other time. That could be on the 23rd, or it could be at a later meeting. If you want to speak, please come up to the microphone, give us your name and address, and I'll ask Mr. Ferrante, since he can stand up there and see the people in the audience a lot better than I can from here, to select the speakers, and I'd ask you to be brief so that as many people as possible can speak. Is there anyone wishing to ask a question?
Let's start in the front.
I'm Wesley Jakubuski, 6 Sunset Boulevard, East Brunswick. The professor from Rutgers, I'd like to ask him a question. Could he explain a little bit more about electrostatic filter, the way that works? Most people here don't understand what it is. I have a little idea about it, but your idea might be more impressive to all of us. Please.
I think I'd have to defer to somebody else who know more about
Your
precipitators.
question is about how an electrostatic precipitator functions?
Correct.
Okay, on this proposal, you're aware of the fact that we have not proposed using an electrostatic precipitator,
It
but...
was mentioned, sir. That's why I'm asking the question.
Okay, fair enough.
Let me just mention my role in that. The electrostatic precipitator was one of the options that we considered in our best available control technology analysis. My role in it is to understand how much of the various substances are going to come out of the stack when the electrostatic precipitator is used. And that's really as far as we went with the electrostatic precipitator. As far as I know, no design win it.
Want to briefly?
Yeah. An electrostatic precipitator is one of the many types of particular control equipment that's available. Basically, it works by imparting an electrical charge as the flue gas to a particle in the flue gas as it passes through a series of gas pass and electrical discharge electrodes. One side of the machine, if you will, is grounded. The other side is giving off a charge. The charge is imparted to the particle, and that's attracted to the grounded portion of the precipitator. That differs from the, although it's a widely accepted and recognized proven technology for particulate control, and as Dan Madigan mentioned earlier, that's the primary one used at RESCO. For the levels that we're dealing at here, in terms of the low emission loading, but perhaps more importantly, the fact that we're looking here at a spray dryer, and we're also depending on that fabric filter to provide secondary SO2 and gaseous species control. A fabric filter was chosen over precip. Both are in widespread application, and one is a purely mechanical filtering action, whereas electrostatic precipitator, as the name implies, use electricity to impart a charge and subsequently collect the particulate.
Well, I'm trying to find out, the diameter of your stack, would that make a film of electrical barrier to prevent anything from being exposed into the air for pollution?
No.
Because the one I'm acquainted with, it makes one complete barrier, a wall.
No,
And anything that's forced through, it's supposed to annihilate it right there and collect it.
The electrostatic precipitator works on the particulate matter that's coming out of the stack, and it will help to eliminate the particulate matter, but it doesn't have any effect on gaseous materials coming out. The gaseous materials would bypass the electrostatic precipitator.
Over here.
Name is Elliot Weinberg. I'm at 8 Clovis Road. I'm concerned about the mention of acid gases and the fact that this carbonate system is not going to trap all of the gases, and that you're relying on the baghouse to collect residual gases. How will the baghouse collect the residual acidic gases? What's happening there?
Right. The nature of the reaction is such that as you pass through the spray dryer, you get a certain amount of SO2 and HCl removal. By reference, I might point out that the levels of SO2 that we're dealing with here are 10 to 15 times less than we see in normal coal-fired applications. The HCl is higher, but HCl and the rest of the fluorides are easy to remove. Now, what happens is that perhaps 10 to 15% of the SO2 removal occurs in the fabric filter because no machine is 100% efficient. So you don't use all your alkali soda ash in the spray dryer itself. This is dried, and as it passes through the dryer, is collected as particulate on the fabric filter, and as the gas passes through there, additional removal efficiency occurs.
Okay. Over here.
Hi, I'm Susan Wisniewski of Jacobson Street in Sayreville. And I have a question similar to what he's asking. I think what we're trying to find out is this baghouse or fabric filter as good as, or is it better than the electrostatic precipitator? I have read that the fabric filters are prone to fires and therefore are not always operating. And the other thing was, what size particles does each take out? He mentioned the number 10? 10 something?
Okay, right. The question of fires, of course, is a remote one here because even though we are dealing with a boiler incinerator application, recognize that it's passing through the spray dryer where we're seeing considerable quantities of water being added to it. So the possibility of fire is basically not there. But you were asking about the
Electrostatic precipitator, what size particles is that? In other words, I'm saying which one takes out down to the lowest amount? In other words,
typically a fabric filter will remove all other things being equal, and will not only probably result in a lower overall outlet emission loading in terms of pounds, but it will is more efficient at removing smaller particles. The number I quoted was the overall removal efficiency of the particulate matter required edge burrows is like 99.7%. Number of studies have indicated that something like 99.5% of particles smaller than 10 micron, and a micron is 254 thousandths of an inch, will be removed in the fabric filter.
Okay, one other question for you. I noticed nobody mentioned today the auxiliary burner that you have for this thing, which I read in your plans. But that is not the same thing as an afterburner, right? An auxiliary burner is completely different. How come we haven't considered using an afterburner so that we could, you know, possibly rid ourselves of the dioxin that might come out of these things? You know.
Our experience has been, I've been at the Saugus plant since it started up. As a matter of fact, that plant was designed with 3 burners in it. We have no burners in it at this time. I think one of the large or the biggest unknowns concerning combustion of municipal solid waste was the fact that most of the history, even though it was good history, was developed in Europe in much smaller installations. In other words, the physical size of the furnaces was so much smaller that any changes in the refuse could have a very obvious impact on the performance of the furnace. The furnaces that we're talking about are so large and the residual values are so high, the furnace volume and heat release The strategic placement of the secondary air and the arch configuration that Mark talked about just doesn't even require any need for what you're discussing. It's done naturally within the combustion zone. We're burning at temperatures as high as 2,500 to 3,100 degrees. But, however, at Edgeboro, strategically located in that zone is an automatically controlled auxiliary burner that would come into play if
Okay,
necessary.
but that's when you are starting it up, or if it's shut down for some reason, you're putting it back on, or if you have some wet garbage, I can understand that. You need more, you know, you need to get the flame higher or whatever. But certainly, part of the substances that are burned or whatever will rise above that into a cooler area of the,
Oh,
I
during
think this
startup,
fell-
during startup, that's part of the standard operating procedure
right,
for
well,
this
would
plant.
an
That will-
afterburner be placed after that? In other words, any substances would be, any gas, any dioxin, any, would actually be virtually
I
destroyed.
think you'll find that it really isn't necessary.
Well, do you have, wait a minute, do you, for your plant in Sarkis, do you have reports of how much dioxin comes out, the quantities? Have they been measured?
Yes, they have.
Okay, will they work as a guideline for here?
Well, there are basic EPA guidelines. What we found at Saugus was undetectable, basically.
Okay, but you're also, the siting of Sarkis plant is such that it wouldn't affect the population. And here, we're downwind, directly downwind. We already suffer the garbage odors from the Edgeboro landfill. And to think of these possible health hazards really, you know, upsets us. You know?
You mentioned that the siting of the plant in Saugus does not affect the population.
Well, with a westerly wind, it's blown out to sea, as far as I understand from what everybody says.
We have people to the east of us in Saugus, too. Yes, we do. But closest are to the west, but we
There
have
is a
residential
population
dwellings,
in
Point
the
of Pines.
town of Revere called.
Would you be willing to give the committee some of these, you know, quantities that you have for dioxin? Some of the emission, your stack emissions?
We're prepared to share with the committee and with the state, certainly, the results of tests that we performed on that substance. As Dan mentioned, we have found no detectable levels in our stack. And this is through very stringent testing methods. And they're complicated. We can't stand here and describe the testing procedures in
Okay,
detail.
I know.
But we're certainly willing to do that, yes.
Can I ask
indeed.
just one more question to Dr. Reese? Dr. Reese, you said that you tested the 4 different situations with the height stacks. Which one worked out the best? What was the final result? What was the absolute best?
Well, there is, the point I was trying to make was that there really is no best in that you could theoretically go to higher and higher stacks.
I
and,
realize that, sir.
achieve a
But
better
what would be the
ground-
very best for everybody to have? Would you say electrostatic precipitator, wet scrubber, or dry scrubber at what stack height? What was the optimum best? No expense mentioned.
Out of the 9 combinations that I mentioned, the lowest pollutant concentration would naturally be achieved by the combination of the highest stack
Okay.
with the scrubber. So it would be
Which scrubber, wet or dry?
they're, both assumed to have the same scrubbing
No,
efficiency.
well, something about a wrapping of plates I read in a dry scrubber is not good. It's not effective. You know,
I was dealing with the figures that were given to me by Wheelabrator Frye, so I don't know anything about it.
I'm sorry, what was that? What, wrapping of plates?
wrapping, R-A-P-P-I-N-G, wrapping of plates.
No, I think she asked a fairly straight question, deserves a straight answer. And, you know, if you make no financial or economic...
was in your shoes, too.
Yeah, make no financial or economic constraints.
Let them try to answer the question, please.
You go for the, any way Nate may want to quantify what I say, but the highest level of overall gaseous removal, it's comparable with both a wet and dry scrubber. The advantage of a dry absorber is that it doesn't saturate the flue gas coming out,
True.
which gives you some help in your plume rise. Anything you do to the mechanical height of the stack, the taller it is, the further plume rise is, and therefore the greater dispersion that you have.
I know, but in other words, even if it would add more moisture, you could always build a stack higher if the wet scrubber is better. You know, this is what I'm saying.
Yeah, but I don't think the wet scrubber is better for this application because you're dealing with, comparable removal efficiencies. And so then all it's left with is what do you do with, what's the other characteristics of the gas? And the drier, the warmer it is, why the better it is as far as dispersion of the
Okay.
pollutants.
And have you ever considered, like, there's a flue gas desulfurizer, which somebody mentioned here when they spoke?
Excuse me, after he answers that question, could you give the floor to someone else,
Yes, I'm sorry.
please? And then you come back if you
Fine,
want.
fine, I'll be happy to.
Well, that is what we have, because the SO2 and HCl is being removed from the time the flue gas leaves the boiler to before it goes into the fan and out the stack. That's what those two pieces of equipment do, take out the SO2, HCl, as well as the particulate matter.
Okay, thank you.
Over here? No, gentleman behind you. You've already had the floor once.
Stan Fisher, 7 Branco Place, East Brunswick. I have a two-part question about the choice of incineration in general, and secondly, about the choice of this particular site. You've, over the last couple of years, repeatedly pointed out to us how European countries and Japan are going the route of incineration. My question is it not true that the primary reason they're going this way is because of their population density and their lack of land? All of the countries you showed on the slide have population densities varying from 400 people per square mile up to 1,000 people per square mile. The United States has an average of a little over 60 people per square mile.
And New Jersey has a density of 900 people per square mile.
And over 75% of the Middlesex County garbage, of the Edgeboro garbage, is coming from outside of Middlesex County.
I know where you're coming from, Stan. The countries that have utilized this technology, Switzerland has a density of under 400 people per square mile. New Jersey has a density that's twice that.
Okay.
And the available land, considering wetlands and considering other geological formations that are undesirable for land disposal, make it an even more dense. New Jersey is the most densely populated state in the country.
Okay, it's not your cause, but why then is New Jersey is Edgeboro accepting 50% of its garbage per your own application from New York City and New York State?
Good planning, which is what Chapter 326 is all about, would dictate, first, every county develop its own solution. Second, that the solution give as a priority a combination of resource recovery and recycling with minimum use of the land. Preferably, if you go to a volume reduction system such as this, you wind up with a small residue, and if you can find markets for that, you don't need the land at all, except for bulky items that can be processed. The best of all possible worlds would be to follow the planning structure and then deny New York access because the machines don't have the capacity for New York garbage.
Okay, second part of the question about the choice of Edgeboro. You've told us about the plant that's under construction at Peekskill. Why in Westchester County is a plant under construction, I would guess about 40 or 50 miles away from the population center of Westchester County, where you're trucking garbage in, and it's not next to a landfill, yet here you're much closer to the population, much closer to an area that's already having its environmental problems?
Well, in the case of Westchester County, the county government determined the siting issue.
Why? Why did they choose Peekskill?
They looked at a number of options. They made some mistakes on the way to siting plants. They started down in Yonkers, for example. It proved to be an unacceptable site.
Why was that?
It was too small. It didn't have a good surface geology. It was cramped. It was not a very useful site. They went further north into Tarrytown and looked at a site there. That had problems with it too. They settled upon Peekskill. It's a combination of planning and political factors. The judgment that the county made. We responded to that county's request to build a plant at that site.
Would you grant that it's not a coincidence that it's away from the population center, that it's away from the people who would be...
Peekskill is not a tiny town.
I agree it's not a tiny town, but it doesn't compare in size with White Plains, Yonkers, New Rochelle, for example, and it's far away from the people who would, the majority of the people who would complain.
It has a population of about 40,000 people.
But it is far further away from
Agreed.
the greater part
Agreed.
of the population.
Agreed.
And would you you've told us that in Saugus it will cost approximately, it's costing now $17 a ton.
$17.50.
What is the projected cost in Westchester County?
Well, the tipping fee in Westchester County is $17 a ton.
And what additional tax revenues are being raised separately to cover the shortfall between the $17 tipping fee, a ton tipping fee, and the actual cost of the plant?
No, that is the cost necessary for the plant.
What was the referendum?
You're alluding to are other costs associated with developing the entire solid waste management system in Westchester County, which includes costs that the taxing district has assessed for the payment of transfer stations, for the payment of for the development of a residue disposal site, and for acquisition of a backup landfill. Those are added capital costs which the county has assumed as a governmental entity, which are imposed to the user through a solid waste tax district.
That's about
but the
25
cost for the plant, the tipping fee with the plant, is $17. That's high. Thank you.
Joe, make a mistake.
Next, well, we got to have new people.
Hi, Joe.
Hi, Tony.
My name is Tony Nuzzo. I live in East Brunswick, and I'm with COS. Good to see you again. I don't really have any questions, but I have a few
Are we ready for statements, Mr. Chairman?
No, I really would prefer that we limit it to questions at this point.
Then I will phrase them as questions.
Well, if they're going to turn out to be statements, I'd rather you wait till the other people have asked questions.
Then I'll make them bona fide questions.
Fine.
You know that we are a group opposed to you coming here now. A few sentences of background, if you may. And part of the reason for that is that we think we have a lot of time in terms of needing you, or any resource recovery. If East Brunswick continues to do its part with its landfill, and other counties, other towns in this county do their parts, we'll have plenty of time before we need you. Now, logically, it would seem to me that the traffic situation that was portrayed here is not realistic. So I ask you at a later point in time to go into that in more detail, and I urge all of you to study that in greater detail. But the air pollution concentrates me a lot. The air pollution situation frightens me a lot. It doesn't seem to me that you've really considered our welfare as a whole, and I ask you why not. Let me give you the scenario. You may be meeting state or federal standards with various particulates in the air, but we have a high cancer rate in this county. We don't really know why. We have time to explore it. Maybe your little bit of particulate matter in the air now, added to whatever else is there, can only compound what we may be placing ourselves in environmentally. Until such time as the effect of your plant combined with everything else that's out there, including the air pollution on 18 or whatever's in the ground now, or the toxic waste that may have been put there illegally along the New Jersey Turnpike that's coming into wherever, until all of the effects combined can be proven that it's safe, and we have time, why must we proceed? Why can't you give us a study that considers the environmental impact of everything so that we could say that, yes, you're safe, but together with everybody else, you're safe? I don't want to look at you alone. I want to look at you as part of an entity. Can't you do that for us?
Well, part of the environmental impact process does entail looking. That's really a permitting issue, and it's quite. There is a procedure in place for that. And I think Nat can respond to that.
Yeah, the modeling that was done for the plant was done for emissions from the plant alone, but in comparing the emissions to the standards, it's necessary to look to see what the background levels are and how the plant will impact how close you're going to be to the standards after the plant is built. And under no circumstances does the addition of the plant bring concentrations any place even close to standards where those concentrations were not close before. And I guess the only place where they even begin to come close is possibly for sulfur dioxide in Perth Amboy, where the plant makes a minuscule combination addition to the concentrations. With regard to the cancer, I want to say one thing about that. I agree with you. The plant obviously is not going to make a negative contribution to the. It's not going to decrease the number of substances in the atmosphere. But on the other hand, if you're decreasing the amount of material that goes to the landfill, you are decreasing something by building a plant. And I was just reading in the newspaper today with questions about cancer in Middlesex County that the highest
cancer rate was not for respiratory tract cancer, but for digestive tract cancer. And I think that also points in a particular direction as
But
well.
who's to say in the future that we won't be robbing Peter to pay Paul
Well, that's-
with the new way of doing it? And I suggest it may take many years to find the answer. We don't need to rush into this, and we should give the mayor and council full support with their experts so that we could find potential negatives before you proceed. So I hope you have a long wait before you come in, Joe.
Yes.
My name is Tom. My name is Tom Wolke. I'm with the Raritan River Friends of Clearwater. I'm liaison officer to Clearwater on the Hudson River. I have a number of questions which I don't think I have the time to talk about right now. I would like to address one question. I did not catch your name, bearded fellow. Gary. I was questioning the flow figures, 225 gallons of water to be used in the plant. Is that an annual or daily?
The plant will be using actually 38 million gallons per day. Okay.
You're talking about river water now or
Yeah,
groundwater?
I'm talking about the river water.
River water, okay.
For cooling purposes, that water will be taken from the river, will go through the facility, and will be discharged back into that same river, which is at an elevated temperature. There's no loss of water to the river whatsoever. Nor is that, you only change the water as returned to the river at an elevated temperature.
Okay,
I didn't get the answer to the question. What I want to be interested in the answer to the question was how many gallons of water are being through?
The 225,000 gallons is processed water for the plant. The once-through cooling system will take 38 million gallons a day from the Raritan River for use in the thermal discharge.
Has any study
And discharge it back into the river.
Right. Has a study been done on, we have been in a series of fluctuating droughts within the basin, okay? The Raritan River Basin encompasses roughly 22% of the state, from Bud Lake to south of Morristown, out to Hunterdon County, Princeton, and triangulated by Perth Amboy. Has any study been taken into account on the drought conditions now and projected for the future?
Yes, part of the whole discharge study, all types of flow within the river were anticipated and taken into consideration in evaluating the dispersion of that discharge into the river. At that point of the site, the freshwater flow is not a major portion of the river flow at that point. Even under worst-case conditions during a 7-day, 10-year low flow, which is the lowest amount of freshwater that goes past the site over a 10-year period, okay? That number is, I believe, 121 cubic feet per second going past the site, all right? But at that point, the water, okay, the water body that the heat effluent will be discharged into is tidally controlled, okay? So that 121 cubic feet per second is less than 1% of the total water that's existing within the Raritan River at that point, because at that location in the Raritan River, it is all tidal water as most of your flow.
Right. We will have, I would like to, in the future, discuss with your panel and maybe the committee. You realize, of course, you are inside the western edge of the estuary of the Raritan River, and I will have questions concerning your facts on the heat exchange rate. I would like to place one further question to Mr. Ferranti and ask if that is a correct statement that you made concerning the Peekskill plant taking in all of Westchester County's garbage needs.
There are right now, under the intermunicipal agreements, about 45 towns involved. That represents more than 90% of what's available on a
And
municipal basis.
you take in the other counties as well?
No.
Okay. Thank you.
In fact, I might just make as a footnote, the Westchester plant is contributing to the stability of refuse coming down to Middlesex County, because trucks do travel right now from Westchester to Middlesex for disposal. And when that plant comes online in 1984, they will be going to Peekskill instead of down here. Right over here. I've been trying to get South River represented.
You have a good memory. My name is George Wickfish, 42 Ridge Road, South River, New Jersey. I'm rather distressed in a way at the presentation because the presentation does not take into account the total environment. Now, we had a lady from Saraville address us. She was quite concerned. We're quite concerned in South River. Now, I think if you had made a proper presentation, and this is my opinion, please, it should have contained all affected municipalities within the county, not just East Brunswick. But my question is this. I like to separate reality from models. Now, we talked a lot about models, okay? What will the effect be on cost of garbage to our municipality? I'd like a dollar and cents figure. You've quoted landfill figures, which is fine. What will the effect of this plant be on our garbage rates in South River?
It's a fair question. We're not in a position to answer right now for one good reason. We haven't put our petition before the regulator who will determine what the tipping fee is at this plant, and that is the State Bureau of Public Utilities. And their determination on how this plant will be financed, how the permissible financing methods will have a direct impact on tipping fee. And until we file our petition and hear their response to our proposal, I cannot give you an answer to that. I can tell you this, though. I can tell you this, that when you're looking at landfill rates that are increasing, in some cases 4 times, and get into the $20 per ton range, because they're forced into environmental compliance, you're looking at the range of resource recovery. We have traditionally equated it with a landfill that has full environmental compliance.
Well, to be fair to that statement, you're still looking at increasing energy costs on the part of electricity, and you've got to be competitive. So, I mean, make a fair presentation, which I can understand and equate in terms of dollars and cents, as it might affect me and my municipality, and I'll accept it. And I make that statement to the committee. I really feel what's involved here is not East Brunswick, it's Middlesex County. And I make that sincerely.
We agree with you.
Well, please, your presentation should have considered it. But, second, with regard to pollution from landfills from resource plants, do you have any actual data that says you've got test well sites that can measure pollution levels of incinerated material that has been landfilled? Not models, not models, actual data.
We do. And in fact, we've included it in our environmental impact statement, the results of those tests. They're ongoing. They commenced a number of years ago, and they're continuing. And in fact, we've included other tests, not by our own operations, but by other people who have performed tests on similar facilities. Dan, you might want to go into a little more detail on that.
We performed a test at Saugus in approximately 500,000 tons of ash residue generated at our plant and stored at the adjacent landfill site. The test, and it's not even finished yet, consists of 4 core holes, 2 inches in diameter, right to the very base of the residue disposal pile, through some refuse underneath, and into the water table below that. The samples taken from the core holes amounted to about 36 samples taken at 5-foot intervals from each hole and fully analyzed and tested by the University of Massachusetts in Waltham at the Waltham Experiment Station. Not only that, 2 of the core holes are still there, left with caps on them to go into the water below the site. We've tested all the water in the sites as well. So that's on the record. And as a matter of fact, we have ongoing tests where we do a lot of work with ash residue in conjunction with the University of Massachusetts. And that program is still is in place and will exist for the next 3 years. It's already 3 years old. So we do a lot of work in that area.
But you have no long-term studies, correct?
Yes, we do.
How long?
Since the inception of the plant, 1975 to present.
Is that data available?
Yes, it is.
Yeah.
Here, tonight?
It's we included the UMass study data in the EIS.
In the appendix.
It's in the
Full
appendix.
report.
It's volume 3 of the application.
It is available?
Yes, it is.
Okay, thank you. I have one final question, please. Another point that concerned me in your presentation was, I'll accept what was said with regard, I don't agree with your scrubbing system, incidentally. That's just a point of view. I think there are more costly but more efficient scrubbing systems, and I speak as a professional myself. My question is this. No one on the panel addressed themselves to NOx levels. The slide was presented, and I don't believe that scrubber, in my technical opinion, would satisfy the NOx levels suggested within that slide. That scrubbing system does not lend itself to NOx scrubbing efficiency.
Agreed. The NOx generation from refuse is essentially very much smaller than a typical fossil fuel-fired power plant. I don't believe there's any fossil fuel-fired power plants that have any kind of scrubbing system for NOx. There are some
They do, sir.
state-of-the-art
Chemical destruction. That's quite common technology. I beg to differ with you. I'm a chemical engineer myself. Yes, you can. Chemical.
Okay, the NOx that we do have NOx emissions coming from the plant. They're documented by EPA studies. The work done by Nat Reese indicates that they're well below any levels, EPA, state, federal regulations. We control basically through the control of air inside the furnace. There's sufficient residence time and lower temperatures. NOx traditionally needs high temperatures for formation. The extreme high temperatures are not present in a refuse-fired furnace, and essentially we don't have a whole lot of NOx to talk about. The scrubber will do nothing for NOx removal. It's not intended to.
My last comment, Mr. Chairman, and I want to thank you very much, privilege of addressing you, is that I would like to make a comment to the committee that they not only address concentration levels, but total loading levels, pounds per day. None of that was made as part of your presentation today.
That information.
There are a lot of points, George, that we did not cover in the. We did run considerably over what I had indicated to the chairman would be our formal presentation time. We do have that information available. It is included in our application. We did limit the discussion. That's true.
Mr. Chairman, thank you very much.
Back up front here.
Excuse me, may I address you, please? I have to catch a train in
Go ahead.
20 minutes.
Fine.
Okay, my name is Madeline Hoffman. I'm the statewide coordinator of SMOKE, which is a coalition of community groups across the state who are very concerned about the building of garbage incinerators. I have a couple of questions to address to the people from Wheelabrator Frye. First of all, if the experience with If the experience with burning of garbage in garbage incinerators has been so wonderful and wonderfully successful all across the country and in Europe, why has Switzerland decided to totally abandon their building of garbage incinerators? And why have garbage incinerators in Switzerland been the primary source of mercury and cadmium pollution in the air?
Okay,
And
let
why,
me respond. Let's take one question at a time,
but
Ms.
no,
Hoffman.
this is part of the same question. This is part of the same question. In the United States also, there are at least 10 major companies, including Westinghouse and General Electric, according to testimony given by an incinerator operator named Alexander Nollett for ENCO, at least 10 companies who were in the business and went out, and other companies who refused to get involved with the building of garbage incinerators. And I want to know why that has happened in the United States and in Switzerland if the building of garbage incinerators is so lucrative and wonderful and
I
successful.
would be very interested in the source of that information because it's directly at odds with the stated policy of the Federated Republic of Switzerland. Right now, they employ these systems to handle about 60% of the waste. The projected utilization factor will be 90% by 1990. So in fact, it's the direct converse of what
Well,
you're saying.
I've seen a
Now,
magazine
may I
article
also
from
continue with
Switzerland.
other affluent advanced countries? In the case of West Germany, the projected utilization rate will exceed 60% by 1990. We have similar long-range plans for every major developed European country. Japan, which I think nobody can badmouth in terms of advanced technology, has utilized, as you saw in that chart I showed, over 100 plants, and they're continuing to build them. In fact, they have acquired these plants most rapidly in the last 10 years, more than any other country around the world. So I think, quite contrary to what you're alluding to, this
I'm
is
not
the dominant mode and will
alluding to anything.
become
I
and
have
continue
seen
to be.
magazine articles that were written from Switzerland explaining it, and I have also seen the testimony given by an incinerator operator.
I'd rather not
Yes.
have a debate.
Okay. But that's the one
I
question.
think you have to go to your basic source. Go to the Federated Republic government and get those documents rather than secondary sources like magazines. I urge you to do that.
The second question that I have is that there have been studies performed by Dr. Barry Commoner and others which have indicated that in all incinerators tested in the United States and Europe, there have been dioxin emissions. You've said that there were no detectable dioxin emissions from Saugus. I want to know how that can happen when in order to destroy dioxins you need temperatures of at least 2,200 degrees Fahrenheit, and you also need some other kind of air pollution device other than a scrubber or a baghouse, which does not do very much to control toxic organic emissions. Also, in a incinerator that one member of our group visited in Connecticut, he saw entire bundles of newspapers unburned after the whole process of incineration.
There again.
So I'd like to know how it can be technically and scientifically that there's no emission of dioxin.
Well, okay, we said, and I'll go again on record, we'll share the results of our test. The basic fact is that you're quoting 2,200 degrees, but we're talking really that dioxin is destroyed at temperatures considerably lower than that. In fact, in the 1,400 to 1,600 degree range. And that's a point of scientific fact. I don't know where you're getting your information from, but that's a point of scientific fact. Your other points about other installations are probably accurate. I can't speak to what an incinerator in Connecticut does. I can speak to what our plant in Saugus does.
Technically, you haven't told me one thing in your plant that would be able to destroy the dioxin emission from
Well,
the
we
knowledge
did. We
that I
just
have.
did. We told you temperature and time, and those are the points.
Thank you.
I'm Leo DeRosiers, 2 Milton Avenue, East Brunswick. I have 2 small questions. Is there any provisions for redundancy in the plant as a safety factor?
In what area? There's a lot of redundancy built in.
Because you didn't extrapolate on it.
What particular feature?
Well, in safety, as far as safety is concerned.
Safety, wow.
You know, your metering of all this, the testing that you're going to be
You mean
doing.
monitoring?
Your monitoring,
Okay,
yeah.
why don't you speak to monitoring?
Sure. Well, each boiler has an independent train, and the baghouse, as I mentioned, the fabric filter has 8 compartments, and it can be run with 6 of those, any 6 of those 8 in service. So you basically have what you might consider 33% redundancy, in that you have 2 compartments for cleaning or maintenance. In the spray dryer itself, when you get into the details of design, we have a multiplicity, perhaps in the order of 12 to 15 nozzles that we would use, that we would run at below rated design. That, coupled with the fact that you can remove a nozzle from service, means that, should a nozzle plug or a desire be necessary to remove it for inspection, you could take that nozzle out, the liquid flow would redistribute itself to the other nozzles, you would get the full amount of flow and the full performance out of the equipment, and yet still be able to maintain both pieces of equipment online. And then in the soda ash preparation system, it's fairly common practice to have redundant and standby pumps to be able to, on both the solution feed as well as the dilution water that you're putting in there, where you can have 200% capacity pumps be able to provide the solution through either one of those.
My second question, as far as lead is concerned, as a layman, where does lead come in to household garbage? Where does it come from? What produces it? The cadmium and all the rest of it. I can see it coming from industrial garbage. I would like to know where it comes from in household garbage.
Yeah.
outside of throwing 100 gallons of paint in there or something.
Cadmium is primarily from glossy finishes, newsprint, magazines, and so forth. Some of the color that they use to make the glossy pages in magazines contains cadmium. That's the primary source. The lead comes from, some of it comes from tin cans and joints and aluminum cans, things like that. Solder, very minute amounts, and whatever other things you'd find like that. Metals melting in the refuse. As a matter of fact, in Massachusetts, we just enacted this year the bottle bill, and we were for the bottle bill because we don't need the glass or the aluminum cans. Those are the primary sources in
Thank you.
household.
Before you take any more questions, we normally stop these meetings at 11 o'clock. I was just told by the camera crew that we have about 10 more minutes worth of time on the tape, and when that time's exhausted, we're going to adjourn the meeting. Continue with the questions.
Right up here?
Thank you very much.
Oh, no, I
No.
was trying to get over your head.
Oh, I'm
Okay.
sorry. The opportunity.
I'm Eva Beatty, 19 Kings Road. Why did Wheelabrator Frye chose a dry scrubber as opposed to a wet scrubber? Are those costs comparable?
You want to speak to that, Mark?
Well, basically, the scrubbing option that was chosen was the most expensive of the ones we looked at. I heard someone allude to that more expensive options, but we looked at basically a wet scrubber, dry scrubber, and we chose what we felt was the best from the standpoint of operations, from technical performance, and it happened to be the most expensive.
Thank you.
Nat, do you want to add anything to that?
Yes, just briefly, with regard to the ground level concentrations of the various materials that would come out of the stack, the dry scrubber does give you better performance in that regard than the wet scrubber does, because the wet scrubber gives you the cooler, lower plume.
Let's get some people in the back because my finger doesn't go back that far. Wait, over here on the aisle. No, well, okay, Lee. I was trying to get behind you too, but you go first.
My name is Lee Carazola, 25 Gates Avenue. I would like to know what provision will Wheelabrator Frye use to prevent toxic waste from entering the facility?
Okay, it's a good question. It's a fair question. There are a number of procedures that we have in place as a normal part of our operation in Saugus. Dan, you might want to cover a couple of them, and then I will go into a little more detailed examination of it.
Well, especially at this facility.
Fine. We're going to continue a lot of the same operating practices because they've worked at Saugus.
Joe tells me that they're going to be more sophisticated about it here. Let me just try to answer this honestly and practically. We have 62 employees at Saugus. Every one of those guys at one time or another involved directly in the charging chute, down on the grates, in the undercarriage, directly involved with repairing the equipment that handles the waste stream. Obviously, we don't want to subject our employees to that sort of risk. The other thing is there is no need for my company to fool around with toxic waste or anything like that. I get all the residential waste I can handle, and it's much easier to handle and no problem. There's no incentive for me to fool with that stuff. In Massachusetts, as a matter of standard, there was very little said about hazardous waste when we first started up, to be perfectly frank with you, and I think there should be a lot said about it. I think we should all be concerned about it. When RCRA finally was enacted, and people, you know, every state agency got very involved in it, and what we have as a standard procedure at Saugus is any commercial haulers that come in, and they're quite limited, roll-off containers, things, open-bodied trucks that things can readily get into, we periodically check. And the standard inspection at Saugus is to dump the load on the pavement and just inspect it visually and document it. Another thing that occurs is that the health department in the town periodically comes in and inspects the loads in Saugus at will. They don't tell me when they're coming, and they just ask me to dump that load. We want to look at it. Also in Massachusetts, the Department of Environmental Quality Engineering utilizes the services of the Department of Natural Resources enforcement agents game wardens, more or less. They come in periodically and request that certain trucks be dumped. We cooperate in any way that we can because, as I said earlier, we don't want the stuff at our plant. And also, we have such good communication with the various agencies that they may occasionally call me and say, watch out for this particular company. There's no advantage for a resource recovery plant to fool around with that sort of thing. That's the practical aspects. From what I understand, Joe, is the people here on the Edgeboro project are going even further.
Well, we are providing for a station, an on-site station, for a local or state government health officer or enforcement officer, so that there'd be an opportunity for continuous, if needed, inspection of what is being disposed of at the plant. In addition, we do have television monitors at the charging hopper and into the pit, so that we do have the ability to continuously observe what is being discharged, not only from the people in attendance in those areas, but from remote locations. As Dan said, we're in the business of handling municipal solid waste. There's more than enough for us to deal with in Middlesex County. Our charter here would be to respond to Middlesex County municipal waste streams, whether they're hauled by a municipal truck or under contract with a municipality. That's our source.
I'd like to add something else concerning that, and this is a practical thing that I think people should consider. If you were to haul hazardous waste and attempt to dispose of it, probably the worst place you could take it to is a resource recovery facility, because the waste that goes through my plant, for instance, is first looked at by a scale operator, a traffic controller. The traffic controller at my plant is a former owner. He owned a small company, so he's familiar with the industry. Then the crane operators observe it. The supervisors observe it. And if you were working there, or if I were working there, you certainly wouldn't take the risk of fooling around with something like that or being exposed to it. So the guy bringing it in is taking a greater risk, because it's not just some guy at a scale house at a landfill or taking a ticket that says go and dump it. There's several people that may have to get involved with it. So it's not very wise to bring it in. Everything is very well documented at a resource recovery plant.
Joe, on another issue, I would like to know where would the power lines go that would supply PSE&G, or if that is the group you intend to sell your energy to?
That's really a call by the utility. The actual alignment of the power lines is a judgment call made by the utility, how it best interfaces with his transmission system. As Mark mentioned, however, the power lines that would be associated with this facility would be ordinary utility poles, not high-tension towers.
And I also would like to know about the ash residue in terms of you intend to ship it to the Edgeboro landfill. Do you need permission from the Department of Environmental Protection to do that? Are you in the process of securing permits?
We don't believe that it will be categorized in any other category than a Type 27 waste, which is an industrial, non-hazardous industrial waste, which is eligible for disposal at the Edgeboro landfill. But to fully answer your question, we'll have to go through a process with the DEP so that they will be able to certify it as such.
And if let's, for instance, if you do not receive those permits, what would be the additional truck traffic in terms of your study that would be caused by having to haul it out of the Edgeboro facility?
I'm going to have to make this the last answer to the last question. Jim, after we've adjourned the meeting, excuse me, it's not his decision. There'll be more than enough opportunities at some later time to ask questions. We'll make, excuse me.
You handled it totally wrong. Totally wrong.
You gave them 2 hours.
We sat here for a procedure.
Excuse me.
2.5 hours, sir.
I gave you all the time that the committee had reserved for its own purposes.
No, you didn't give us the time.
We heard a 2.5-hour lecture on
That's right,
technology
2.5
that's way
hours.
beyond most of the people here.
This isn't...
One input into this procedure Give us an opportunity to ask the right question.
You will have. This is not the last opportunity. I tried to make that clear to you at the outset of the
I
meeting.
have one question I have to ask, which is not, that I really want an answer from you, Mr. Chairman. May I have the floor for 1
No,
second?
may I answer this gentleman's question?
If I can get a question in before we leave tonight.
Lee,
You
the answer is
certainly can
30
ask
trucks a
questions
day.
before these gentlemen,
30 trucks
before
a
we
day
leave
more?
tonight. But, excuse
No, it
me,
wouldn't be
let me
more.
finish.
It wouldn't
But
be
we are
more,
going to
because
adjourn the
there are
meeting
offsets
formally.
from the
Anyone who would
landfill
like to
trucks.
come up and ask questions and discuss the application is welcome to do so after we've done that. And there will be further opportunities, starting on the 23rd, for you to ask questions.
I pick the people.
Learn how to conduct the meeting.
I picked
Excuse me, you want to answer, Mr. Ferrante, you want to answer the last question?
I did.
And then we'll adjourn the meeting.
30 trucks a
All right.
day.
The meeting's adjourned. Please come up if you have other things to ask.